All right, everybody. Says we're live. Yay! All right, sorry for the little bit of a delay. I was trying to fix a bug I introduced before getting started. Um, because of course I made a stupid typo. That always happens. Hold on, let me just fill my glass up with some Coke. Yo. All right, I hope everybody's doing well. Nearly Christmas. Don't know how many of you guys celebrate Christmas, but to anybody who does, Merry Christmas. Everybody else, Happy Holidays. Yeah, probably going to take some time off in a couple of days and actually enjoy a bit of a Christmas break. But I might end up still posting or maybe even doing a stream just for fun. But yeah, we're back at XR Tools. I was working a little bit on our little construct setup, so I really need to rename that. I think construct in this case is a bad name for this helper scene, but the whole idea, of course, being here that um, we have a view specifically for what's the right word? For people on the desktop. So this actually I need to change that. Have I already changed that? I might have already changed it. Yes, I already did change it because one of the things that I am doing differently now is instead of making exception for when publishing this to mobile, I've made the exception for if we're running on PC, which in this case means Windows, Linux, and Mac, which is really nice. So if I am, by default exporting to any sort of device, or if I have a reason that I don't actually want this to turn on, there's ways to override that. I'm just loading our main scene, which is, just to quickly go back here, which is obviously our actual stage setup. So this is the scene that actually has just a default player rig, which is only used to actually I should go to 3D, which is only used so that we can see our little loading logo. Now we can see a background here, a sky that is actually disabled because on this camera, as you can see here nicely with it being black, we actually have a overriding environment that turns off the sky. And this is basically just displaying the loading screen by default so that we actually load the real level that the user is playing in. We load that in the background. That gets added to the scene node. And then when the loading finishes, we fade out of our loading screen. We fade into our actual loaded scene. And then whatever player rig is set up in the loaded scene takes over. If we want to change from one level to another or from one scene to another, we do it in reverse. We black out the screen, remove the loaded scene, load up a new scene in the background, in the meanwhile showing the loading screen. So that is basically the setup that we have here. This needs some more improvements at some point, but it's not really that important. But anyway, the point being that is what is loaded by default on a standalone headset. But if you run on PC, we run this construct scene, and all the construct scene does is it has a default output. So we're using a desktop container. That's a object that makes sure that whatever subview container or subview that is held within is actually displayed on screen. So this is actually the output that the person sitting behind the computer sees. And you can do anything with it. So in this case, we're mimicking the loading image, and we're mimicking, or in this case, we're setting up a spectator camera. And that's what you guys have been seeing in the previous couple of streams. But we're actually outputting the view that you see inside the headset. We're outputting that to this viewport. And you can see that that main scene that we had is now simply a child scene of the sub viewport. So everything that happens in here is rendered to the sub viewport, is displayed on our headset, and everything that we're doing over here is being output to the screen, and people watching on the monitor can see that. Now, we're using that in this project to create a third-person view. And we have this nice little stand-in camera here that you can only see when you're inside of the headset, so that you have an idea of what people see. Again, optional thing. You can turn that off if you want. It's just a little helper for me to know where the camera is, where to look when I'm engaging. But you could do anything with this. So you could remove these. These are also, like if you can look at this, this is the scene that's in Extra Tools itself. It's just a construct, which is why it's called construct. Still not sold on that name. You can add anything you want there. So it doesn't even have to be a 3D thing. It can be completely 2D. Think about a game like Keep Talking or Keep Talking and Nobody Explodes, where the desktop player is seeing a completely different interface from what the person with the headset sees. So the desktop player is seeing the manual of the bomb that you're trying to defuse, and the person in the headset is actually trying to what's the word? I just said it. Defuse the bomb. Hello, Black. Just want to say hi. I find your work very interesting. Sadly, I need to go. Oh yeah, that sounds very late. Well, I'd say well, sweet dreams, and well, thanks for joining in for even a short time. Yeah, thank you for finding the content interesting. Okay, why is my nose itchy? That's really annoying. So that is what this setup is all about. So in our little demo for Extra Tools, we are using the spectator camera. But I was working on this because I wanted to make alternatives, because for something that I'm about to work on right now, I actually need to be able to switch between things. So when we look at this, so if our loading screen is showing, we disable 3D. So that means that we're no longer rendering any cameras. That's cool. Showing the loading image. Perfect. That means that whatever camera I've got active, that's not going to do anything. And yeah, I do disable that just as an extra. That's cool. Sweet. Okay. Perfect. But I want to actually add a number of camera options with the ability to switch between those camera options. And one of the camera options I want to add in here that I've already used in like one of my tutorials is a stabilized camera. So a camera where you are seeing what I am seeing on the headset, but where it's an extra view that is rendered. Oh, that reminds me, one other thing that is important to note here is notice that there is a desktop FPS here. We're actually rendering this viewport at a lower frequency. So while we're updating what's in the headset at full headset frequency, which is currently 90 frames per second, there's a little bit of logic, and it's not super accurate. This is a target. It's not like it's exactly going to be 30 FPS, but there's some code in the, I need to then go to the base class. There's some code here that that will only set update once on our viewport whenever a certain amount of time has passed. And basically that ends up resulting in the sub viewport only getting updated like once every 3 frames. And the other 2 frames, obviously it's still rendering output, but it's just rendering whatever the last output was that was rendering. So it's basically just a copy. And that's just to minimize the performance impact on the desktop, because we don't need to have that running at 90 frames per second. That's just overkill. The other thing which is really interesting here, which I haven't done much about, obviously the size gets automatically resized to the actual window size. So that is not what we're rendering on. We're actually rendering on the full resolution of the window. But I can do additional things here, right? So I could say, for instance, say that I actually want to have a little bit of MSAA nicely on this viewport so that we get a nicer output. Now that reminds me, is MSAA actually turned on over here? Where are you? Anti-aliasing? No, it's disabled over here. So I might actually want to do something like, hey, let's go and enable that so that that is the default MSAA that we would be getting on our headset. But we don't want that on our main viewport if we're on PC mode. So this is a way that you actually do that. You go here to this drop down, you select PC. So now we do that and we say add. And now you can see that I have a 3D PC version. So the reason I'm doing that is I'm already applying my MSAA to the viewport here. That now gets, through the desktop container, that now gets copied out to screen. I don't need the screen itself to run MSAA. We've already applied MSAA. That would just be a waste of performance. Now, at the same time, I now have the sub viewport here. And again, I might need to set some of these actually on the parent one, but I'm just doing that as an example here. Is that obviously also means that we should turn MSAA to 2 times over here, else we wouldn't have MSAA enabled inside of the headset. So it's important to know that these project settings, they apply to the default viewport that is output to screen that we don't actually see in our node tree. It exists behind the scenes. But that we need to, if we have our own sub viewports, we have to set the quality settings that we actually want to use there. So with this, we have, when we deploy directly to headset, MSAA 2 times enabled, really cool. We now have MSAA 2 times enabled on our VR sub viewport when we're in C mode, and we have MSAA 4 times enabled for the beautiful viewers at home. So that is the way that we can set that up. All right. So with that, I want to go and implement my my stabilized camera. So I've done this a couple of times already. I might actually go and quickly. I don't really want to reinvent the wheel. Just on my other screen, I'm going to cheat and bring up my old implementation, if I can find it, that is. Of course, this is not the one that I'm looking for. It's in here, I think. My microphone is actually in the way. Here we go, spectator view branch. So spectator, here we go. Okay. I'm going to keep that on the other screen and look at that from time to time. So one of the things, other things that I'm doing here is instead of just adding, because I can just add a camera 3D in here. And now I could switch between this camera and this camera. So there's a current tick box there that you enable or disable. It actually exists behind the scenes on this one as well. I was thinking about mirroring that in the view here, but I'm not entirely sure if I will do that. But I might. For now, what I've done is in this scene, in the script, I actually have a make current function that I can call to make that camera current. Now, the nice thing about this, and this is one of the reasons why I'm not sure if I'm going to do it with an export variable / property, is whenever you make a camera current, it turns the other cameras on that same viewport, because it's a current camera per viewport. It turns the other ones off. And there's some magic behind the scenes around redrawing, and don't really want to, be too bothered with that. It might actually work. I might actually do it that way, but for now, I've not done that. But the other thing is that I've actually got the whole camera set up underneath that. So yeah, that is stuff that I then. Oh, I don't know. There's a part of me that says that should actually be the root here, so that we actually have access to a lot of these things. But right now, I've chosen to just do a Node 3D as a root, just to hide a whole bunch of functions and properties that don't really apply to what we want to do, where we don't actually want the user to get confused and start overriding stuff and placing stuff the wrong way. Plus that we are positioning that spectator camera, and we want to do that in a way that doesn't counter what the user has done in placing the root node. Anyway, we're going to mimic that same approach for our stabilized camera. So let's go and add a node here. No, one lower. Thank you. I'm gonna actually I can move that one there. And we're gonna call that XL2 stabilize. Probably spell that wrong. I'm very good at spelling. Not. All right, cool. And obviously, because I did it that way, yeah, that is of course going to go and screw that all up. So, and I probably screwed up the rotation as well. So let's undo the rotation on this. I should have just recreated that on the proper node. All right, so cool. So there's our stabilized camera with the camera as a node just on the root there. Now notice that this is obviously not doing anything with the origin node and things like that. So that's stuff that we are going to have to do behind the scenes. All right. So let's go and save this in our assets. Nope, not our assets. In our add-ons. I'm going to keep using that construct folder that I've got everything. So here I've got my construct and I've got, oh, I already have a stabilized camera view. Let's go and have a look at how I implemented that and whether I did a good job at that. So let's go and just insert our stabilized camera there and have a look at how well that one works. And maybe we need to clean it up a little bit because that is an old implementation. I didn't realize I had already built one of those. So now I need to have a bit of a thought because, yeah, that is one of the other things that that is really important to note is we've given this a class name so that we can actually interact with that class. But the moment that you have that class name, what I can also do is I can press plus. Then I can actually find the XL2 stabilized camera here, and I can add that one. But that one now is not working. So I just wanted to name that just real quick. Because we now have added a node of that type, this node doesn't actually have all the scene components. Now, there is an argument for saying, let's build that behind the scenes and make this properly work. Well, for something like the spectator camera, there's just too much in there that I don't want to deal with. But for the stabilized camera, I could do that. I'm not going to, but I could. And the other thing that I want to do here is I want to click on this make local. No, that is not what I wanted to do. What is it called? Make. What is that option? Make unique. That's the one. So access as unique name. Now notice that there's now a percentage sign behind that node. And the nice thing about doing that is that I can now reference that node by its name without specifying the whole tree. So I don't have to do desktop container / sub viewport / stabilized camera. I can just do % stabilized camera, just like we've done here with the spectator camera. So with those in place, let's have a look at the code that's on here. So we do have our make current. We already have our process. So our process in this case, right, positions it. Now, this is another thing that I really want to do real quick. So I want to give this a default height. Doesn't have to be accurate, but I want to give that a height. Just so that if we go and look in our... that's why. If we go and look in here, we can see that actually our camera is a little bit up there and not on the floor. So that's another reason to have that little scene. But in code here, we are actually overriding that. Now, this is where I wanted to have a quick look. This is something that I obviously have written a long time ago. And I want to see if the approach that I take here is still the same and is doing the proper thing. So I'm getting my adjusted transform from my actual post. So this is getting the positional tracker for my head. So that's giving me a tracker that is tracking the player's head position. I'm then getting the default pose from there. That's going to give me the actual position. If I have a pose and it has tracking data, I am getting the adjusted transform. That is giving me the transform in the XR Origins space of where the person's head is. All right. Then I'm locking that. So is that the right thing to do? Because let me see. I think so. Although yeah, that works. That probably works. Yeah, because I got the negative. Okay, yep, cool. No, that works. It's I've done it slightly differently in my tutorials, but it's basically the same thing that I'm doing there. All right, so I'm giving that a looking at, and I'm moving my camera transfer slightly back. This is the idea of, sorry, I should say slightly forward. I think. Might be moving that in the wrong direction. But the idea here being is that I wanted the camera to be slightly forward of the head position so that we don't render something that is part of the player or part of the avatar. But I might actually be moving it back slightly here. Not quite sure if I'm doing the right thing there. We will see. But I think that is overkill. However, with that transform, again, this is the local transform, the track transform. I am now interpolating that. Ooh, cool. So yeah, so I'm taking the previous transform, the one that we did last time, and I'm actually interpolating. So this means that instead of following the person's head, so I've already removed the tilt, but instead of immediately following what the person is looking at, we're interpolating to sort of dampen the movement of the head a little bit. And then finally, I'm applying that to the transform of my stabilized camera, but now I'm taking the world origin into account so that it's actually positioned in worlds properly. And then I'm storing the previous transform. So yeah, this is working the way that I wanted. I did well a couple of, probably one is a year ago, so did well back then. I'm happy about it. And yeah, then the weight is the thing that we that allows us to smooth that out. How much are we smoothing it out by? And we can play around with that. All right, so there's a little bit of things that I want to do here. The most important one is weight wire. I want to go and add this export variable in there. We're going to rename that in a second. I'm actually going to call that stabilized camera. There we go. And I'm going to make that an unready var. Camera. There we go. Okay, perfect. I also actually want to go and quickly move this and give that an underscore. Just to note that that's a private variable and not accessible from outside. Wait for our position and orientation smoothing. Go. So this is just to make sure that we are that we're only seeing the right things. And in this case, actually, I want this to be 3, and I'll explain that in a minute why that is 3. Now the last thing that we need to do is we need a ready function, and we need to make sure that that is run on our ready. With that, I want to steal from here that one. That's a little bit overkill, but okay, cool. Now I can obviously do this here as well, so that we don't have that, and we can do that here as well. There we go. All right, that cleans that up. That should all work. All right, cool. So with our stabilized camera, hopefully working, and oh, that's the other thing that I need to do. This is always important when, oh, it actually is doing it correctly this time. Because it's always a bit of a question of when you have something open is whether it updates that. So that should also be here. Sometimes it just doesn't initialize these properties that you add properly. But we've added a cull mask property that is going to define which 3D layers we actually end up rendering to the stabilized camera if the stabilized camera is being used. And what we want to do is, because here we are mimicking what the player sees and not an outside view, we want to default that to obviously always having our default layer enabled, but we also want to have the HMD layer enabled, but we don't want to show the things that are spectator only. In this case, yes, this is a spectator camera in the sense that this is the camera that we're seeing on desktop, but it's not a third-person camera. It's a first-person camera. So we do not want to see the things that were added to make our third-person camera work. And that, in this case, when we look at our main stage, for instance, that in this case is our head and our little HMD thing. We don't want that obstructing our view. Those things are also not rendered inside of the headset view. All right, so now we have these two cameras, and one of these two will be current by default. I believe it's the first one that we encounter. In the background, if this were normal cameras, only one would have the current tick box ticked. But if none of the cameras have the current tick box ticked, Godot will enable the first camera that it finds. So, yeah, pretty cool. We want to be able to make a choice here. So that's going to be the next thing to do, is we want to make sure that the user has some UI to select between the cameras that we have. Okay. And we do that with an option button. So we'll just add an option button to our UI. There we go. I'm going to move that up a little bit. I am going to put it under the loading image, even though we're not even going to show that when the loading image is on. And what I really want to do, let me see. Really should be setting up a theme. But I'm going to make the font size a little bigger so that we see some bigger text. And I want in the layout, I want to move this slightly off of the top. Now, normally what I would often do is put this into a VBox container, and maybe at some point we'll do that if we have multiple options. But for now, that's all that we are doing. I'm also going to rename this to camera selection drop down. There we go. And I'm again going to do that access as unique name. There we go. Let's give it some options, shall we? So our first element is going to be our spectator camera. And I obviously want that to be our default selected option. For some reason, that is not sizing correctly. That's interesting. We're going to add another element, and that's going to be our stabilized camera. Yeah, I don't know why that's... Oh, I think I know why that's falling off. That's because that's the end of what it thinks the resolution of my sub viewport is, because I've limited that to that. So obviously that's going to be much bigger. Maybe I should change those default sizes a little. I think that would actually be a good idea, because that's just crazy. Why am I not allowed to? Oh, because the desktop. Yep. So let's make that 512 by 512 or something. There we go. Is that a good idea, or should we do it some sort of aspect ratio? 190 times 0.5 and 1080 times 0.5. There we go. Just to 20 times 0.5. See, that didn't seem like the right size. Okay, cool. Just resize that a little bit more usable. Cool. Okay, so now we can actually see the whole thing because we have a little bit more space. And again, this gets sized properly when the game runs. But at least we can see that we're doing the right thing here. So we've got a spectator camera in there as per default. And we have an option for a stabilized camera. And obviously we can keep building up more options if we want to have other cameras. It also means that we want to make sure that we go and change things when we obviously change this. So we're going to go and hook up our item selected signal. There we go. But it also means in our ready function, might as well abuse that and say, hey, let's by default select our default selection. Make it absolutely stable. So that is our selected property. And that means we can do percentile camera selection drop-down dot selected. So that means that on our first run, we will decide what is going to happen. So here we're going to simply say, oops, match index. Oops. And if that is 0, we want to do our spectator camera. And we're just going to call make current on that. And if it's 1, we're going to say that one. All right. So that should allow us to switch between the two different cameras. What is super and why is it red? Well, it's red because it's a built-in function. And super means that we're going to call the ready function of the script that we are extending. So there's an existing script here, which is called the XR2 construct script, which is this one. And we are referencing it by its class name. If we didn't specify class name, we would have to specify the path to the DGs file. And because this function already has a ready function that does some important stuff, when I write a script that extends that functionality and that has a ready function as well, if I didn't call super, then this code would no longer run. And that would break my solution because it's kind of important that this bit of code runs. So in a situation where you are extending a script and you are implementing a function that's already implemented on the script that you are extending, you have to call into that. And obviously, if this would have a property, then I will be able to send the property through. So, or sorry, not property, parameter. I would also be able to include the parameter there. So I'm making sure that the code in the original ready function gets called, and then I'm doing my additional bit of logic. So I hope that answers your question. Anyway, we now should be able to switch between our spectator camera and the stabilized camera, which would be really, really good if that works. Let's go give it a try. I'm, of course, being thrown out of Steam Link, haven't I? Yep, I have been thrown out of Steam Link because we waited too long. All right, let's connect back to Steam Link. And there we go. I'm in Steam Link. Okay, so let's go and run it. So you guys should see our view. We do. Oh, that's something I forgot. I wanted to hide the drop down on the loading screen. We'll do that in a minute. I just want to see if it runs. So I can see inside of my headset just fine. That bit has not changed. You guys still see the spectator view, but I should now be able to say, let's go to stabilize camera. And now you guys get to see what I see. There we go. But you should be able to see it in a way. So when I tilt, it shouldn't tilt on the screen for you guys. And it should be a little bit more stable. You know, if I really have a little bit of shaky head, it shouldn't come in. I can't see what you guys are seeing, so I don't know if it works well. But yeah, that bit is there. So we have our hands here. We still have our little blue ghost hands that I've added in. I actually want to make it react a little slower in showing, so that little movements aren't a problem. The whole idea about the ghost hands is when we are actually pushing our hand through a wall, so that we can really see that we're not there. But the most important thing is when I now move, notice that the hands stay in place. Oh, I do have that as a problem that I need to solve. Oh, that is interesting, because that makes perfect sense, and that's probably, yeah, I need to make that the logic that I've done to compensate for movement. So if I also do this, it stays proper. I need to make sure that that is only applied for movement that I'm doing virtually. But if I'm doing physical movement, obviously my tracking already compensates. I shouldn't then also compensate for that. So I need to make that smarter. That makes perfect sense. Okay, that is good to know. I need to make a better way of doing that. Not a problem, but good to know that that is something that I need to do. All right, so that is one of the big things that I was really happy about that I finally got right, that moving doesn't make the hands lag anymore. The other thing, obviously, picking things up. So I can pick up this box, and that feels way better than it. Here you can actually see now where the ghost hands are really cool, because now you can see like, hey, my hands are actually inside of the box. But I can't obviously put them inside because I'm holding the box. So this is really where the ghost hands were supposed to be used for. But yeah, yeah, I need to compensate for for actually physical movement. That might actually be a nice one to solve in a minute and work on. But that said, yeah, I'm really happy with how this now works. It's still a little bit, you know, where it's a little bouncy, especially for, you know, picking up something as heavy as this. If I pick up something a little less heavy, like this 2 kilogram thing, does it a little bit, but not as intense. Now, it does still wiggle a little bit when I move, especially with one hand. I kind of, you know, I don't mind that. With two hands, they get stabilized. That kind of makes sense when you're holding something of weight, that we have a little bit of, yeah, effect when we move, that it's actually, you know, it's not featherlight. But yeah, it's one of those things where it's going to be interesting to see how much more natural we can make it. Now, the thing that we did last stream is still a problem. So you can see that that is still stretching. Not happy. So there's definitely some stuff that I need to improve there. And that's the same with this being over here, is as I try and grab it. Come on. Yeah, this is getting worse and worse and worse. For those who saw my last stream, we can solve this by putting my physics rate up. But I'm back to a normal physics rate synced with the refresh rate approach, because I really wanted to work in as best as I can in that setting. But yeah, if we do have to eventually go to a position where we do need a slightly higher physics rate for this to react properly, then so be it. The thing that I want to avoid most, and for that I need to create more objects for us to play around with. It's like if I'm holding a tool like a hammer, is that moving the hammer feels natural, and not that, you know, it feels spongy and weird. Which, by the way, a lot of these sort of toolkits suffer from. So I'm trying to find out what others have done to it, but yeah, it's still nice. I can see that indeed around that 1.6 meter mark. So that's working properly still. This is still working properly. I'm happy about that. Oh, that one I do slide down. I am strong enough to walk up it. And then here we got our sliding ice, yeah, our low friction section. So that is all working. All right, so I need to fix that. I think that's something that we're going to work on first, because that is dumb and annoying, and we can definitely improve on that. We just need to figure out what the best way is to improve on that. Okay. Is it a kind of glow? No, the script here. So I have this as a, and this applies to any script, right? So my script here, my construct script, is the script that is attached to this node. So you can see here, there's a construct.gd script, and that is the script that I have over here. And it has its own ready function and other things. But because this is a scene that doesn't exist in isolation, so like for instance, a spectator camera script, that's just a node, that's just a scene. You can see that there's no little icons here. This is a separate scene, has its own script. And, you know, yeah, it extends from Node 3D, which is the type that it is. So in theory, if I override anything that's in Node 3D, I might have to call Super as well. However, because that is a built-in node, we don't really have that danger. Or you know, there's very few situations where that is. So when we look on here and we find our ready script, you'll see that that's a normal ready script. There's no super call in here. But in our construct, you can see that little button there. You can see that I've actually got a scene here as part of my toolkit. So that's the XR2 construct scene. This is part of the toolkit that has a basic setup. So it adds all the components that you would need to make this system work. And it then has a script, its own script, which is this XR2 construct script, that adds a bunch of logic that controls the system. But it's like a base to work on top of. So in my demo project, so again, this XR2 script, if you look in my file system, in my add-ons, in my Godot XR tools, in my construct folder, you find that XR2's construct script or scene. And the idea is now that you inherit that, you create an inherited scene, and this one actually exists over here. That's the actual one that we're using. And you can see all these yellow nodes, they are all taken from here. So these 3 nodes show up as yellow nodes over here, and I'm adding the things in here that I need. But if I need to also add additional logic to what is in here by default, because normally, where are you? Normally this would just be pointing to that XR2 construct script. But because I want to do additional logic, I go in here, I select the extend script option, and that created this construct.gd file that then extends the original file. So if you look in here, for instance, if I look at the same place, you can see, hey, that is that construct.gd file there. So it inherits that, and again, because it has a class name, I don't have to put the file name there. I can just use the class name, and I just add a little bit of extra logic. Which also reminds me that no, not this one. This one. I want to, before I forget, I want to hide that here, and I want to show that here. So yeah, so it's the whole idea of you create a scene with a script, or you know, it could even just be a script by itself that has some logic, and you then extend that scene to add additional logic or to customize it. And in that situation, you can have, you know, logic that needs to call into the original functions of the script that you are extending. And that's what Super does. Robin, that looks really good. I don't see much of snapping teleport when you grab stuff using grip poses. Yeah, now this is all using full hand tracking because it's supported on Steam. If I disable, actually, that's actually a nice little thing to show. If I go into here, and I go into OpenXR, and I disable hand tracking, so just gonna say don't want to use those. I'm gonna re-enable them in a minute because I do want to use them, but I just wanted to show this. What we're now using is a grip pose or a hand pose fallback, and it's going to work a little bit more janky. All right, so there we go. So this will be defaulting back to the spectator camera. Let's go to the stabilized camera. Okay, so oh, come on. Oh, it's not working at all now. Oh, that is interesting. Did I get the names wrong? Did I change something here I was not aware of? Oh, over here. Might have accidentally changed that. So, got a trigger click here, but I don't have a trigger. Well, it's not going to work if I don't have my actions, is it? How did I lose my actions? Where'd it go? Move palm pose. Now, this is something that I might want to change. So for that, just bear with me for a second. No, it's not here. Here. Actually, let's go and just search where I'm using trigger click in here. Loading screen and hold button. I'm using these. Okay, the reason why I am hesitating a little bit is there are some runtimes that have problems if you are binding both trigger click and trigger, but I'm just going to go and say, you know, that's going to be trigger. And it's going to be, what did I call it? Grip. Whoops, not tip. Grip. Okay, trigger. And this is where I'm really hoping for. This is probably why I didn't originally do this, because in the simple controller we don't even have those. So half the things don't work if you use the simple controller. Go away. All right, so I'm going to add the trigger here. So this is what I mean is we've now got two actions bound to the same input. There are some runtimes that don't like that. It's supposed to be supported, but so yeah, one of the things that that I am planning to change in this eventually is not to rely on trigger click, but instead just have my own logic for figuring out when the trigger is pressed enough. That also actually works way better in a lot of cases, because there are runtimes that have very dodgy, what you call it? What am I thinking of? Sorry, guys, I'm a little tired. They have very dodgy thresholds. That's the word that I'm looking for. And I suddenly realized how did everything not work with grip? We actually have a grab on. So I do want to put the trigger in, but I'm actually going to go back here and I'm going to remove our grip because we actually have our grab, and we need to go and change this to grab and work on that. And the same thing here. We are going to go down to, where are you? Is it tracking? I think so. So that's going to be grab instead. Okay, so let's hook up our trigger a little bit more. So here it's nice that trigger and trigger click are two separate inputs. So on these, it always works. There we go. All right, cool. Then hand interaction. In this case, I believe we can abuse the aim activate here. But if we have the hand interaction, we will be having hand tracking, so our positioning would be done with that anyway. But let's just assume that we can actually use that. I might be wrong about that. It might be a different one that I need to use there, but c'est la vie. And then let's do them this one as well. Although this toolkit isn't really suitable for doing this, so mileage will vary. Now here we do have a trigger click as a pinch, so I guess that's also going to be then the trigger here. And again, that might lead to problems that we're having the same input onto two of them. What did I do here with trigger click? So we didn't even have trigger click in here. Anyway, that's fine. Let's go back to this and see if it now makes sense. So that thing's still working. That's a good sign. Yeah, working fine. So here we go. We can see our hands. And now we can see that our trigger moves our finger. That one moves that, but it's no longer smooth, right? It's now, it just snaps into place. When we are looking at the actual objects, so come on, go away, Bull. My sorry, my computer was in the way. I couldn't put my hand far enough. But when you see, and I actually want to put this back on a table. There we go. Oh, come on. There we go. You see this, right? Oh, come on, go back on the table, you. So as I grab it, you can actually see that the hand moves to the object, and now I'm pulling the object towards where my hand is. And the friction in this case is actually stopping it from doing that. So this is what actually makes that much smoother. So in XTools 1, when I did this, I would immediately have the object move to where my hand is. But I'm doing the other way around. I'm actually moving the hand to where the object is, and now I'm pulling the object to where my hand is actually in space. And that gives it that much more smooth interaction. It also means that when I look at, in XTools 1 where we have our remote grab, which I haven't got there yet, I actually want to change that we don't actually grab the object until we manage to move the object close to where our hand is. So that is another thing to work on. And I'm actually thinking for that to not combine that with our pickup function, but to do it more like what Half-Life Alyx does, like a gravity pull, that I can pull that, can hold my grip, and I can pull it towards me, and then I need to catch it. So that's future music. That's not yet for now. All right. So yeah. So there's some stuff there. Anyway, so we just found a problem and we need to fix it. So let's go and do that first. I'm actually happy now with my improvements for my stabilized camera. So what I'm first going to do is I'm actually going to go and put those in separate, and I'll clean things up behind the scenes eventually. But for now, what I just want to do is create some new branches here, and this is improve spectator cameras. There we go. And now I'm going to say add dot commits, make some improvements to the spectator camera. There we go. And we're going to say put that in. So there we go. And now I'm also going to do a git checkout -b, and I'm going to call this more hand improvements. I might have already had one of those in the past, but hey, thingy needs a name. I'm going to add another terminal here. So that was in the add-ons folder. So that's the add-on that I have actually checked in. Now we need to do demo, so we can see that our demo is linked to a new commit on that. So this is how submodules work. I'm a big fan of submodules. Although for anybody who wants to test this, be aware the main branch is actually our add-on, which you can sub-module into your project if you want to use extra tools in your own project. Although there will eventually be deliverables that we can actually just unzip it or install it through the asset library like you can with Extra Tools 1. But if you want to try the demo that we have, the demo is a separate branch on the repository. And that branch has... Why are you... Oh, hold on a sec. I've missed some... Oh, will you stop it? Thank you. I need a new headset for my phone. Somehow. Okay, cool. Somehow, I think my cat's been playing around with my headset. So my phone headset, those are my earbuds. And I think there's a break in the cable, and now when I move the cable in a certain way, my headset thinks that means that I'm toggling play, and it starts playing music all of a sudden. I actually need a new phone. I just haven't been bothered to buy one because my speaker on my phone is broken. And it is such a pain to buy a new phone. And well, Apple makes it relatively painless to move all your stuff from one phone to another. Probably Android too. I just don't have any experience with it. Anyway, sorry, that's a whole tangent. I hate buying new phones. I'm so happy with my phone. I've had this thing for, I don't know, 5-6 years, and it works perfectly. And I'm sort of going like, it still works perfectly, and it's just a freaking speaker that broke. Can't afford really to not have it on me. Back to this. So as I was saying, so the demo actually submodules the main branch, or in this case, it now submodules the branch with the spectator camera changes. So it's important that if you want to try out the demo from the current repository, the repository currently is on my personal repo on GitHub. It will eventually move to Godot VR. But I want it to be a little bit further along before I move it there, just to prevent people from jumping on it too quickly. But if you want to then clone the demo, you have to make sure that you clone it recursively so that it also pulls in the plugin. So with our spectator camera branch in there, these are now our spectator camera changes for the demo itself. So what I now do is, on the root, I do the checkout -b as well. So checkout -b actually means create branch and then check out that branch. And I call that demo then with the same thing. So I've got improved spectator cameras for my changes, and I've got demo improved spectator camera for the demo changes for those changes. Boom. I'm doing it add dot. And I can say this and set demo changes for spectator camera improvements. There we go. And now I can say git push origin improve spectator camera. There we go. So those two are now nicely on GitHub, and I'll clean them up and stuff. But it means that I can separate out the changes, which is kind of nice. Now, with us now here being on more hand improvements, I'm also just so that I don't forget, I'm going to do a checkout -b on that. So, oh, not more. That needs to be demo. More hand improvements. Okay. So all my changes always go in unison. The changes to the plugin itself and the changes to the demo that use the changes of the plugin. And they will be merged together. And eventually, both will be used to build a release. Okay, with all the changes that we've done so far on stream safely put into their own branch, we can start concentrating on actually fixing up this problem with our hands. Now doing the correct thing when I'm moving virtually, but doing the incorrect thing when moving physically. It's going to be a little bit harder now to solve this, Right now, I've got logic in my collision hands that sort of automatically do this and don't make any assumptions. Let's go actually have a look at those. Also want to close a couple of things that we no longer need because it's only confusing to have those open. I did close one too many just now, but that's okay. I want to close that. I want to close you. And now I want to reopen the one that I closed by accident, which is my main stage. There we go. All right, so here we go. We've got our collision hand. So let's have a quick look at what it is that I eventually did to make everything work. As you'll see, there's quite a few changes since my last stream. One of the big ones is I'm no longer using my pit controller classes. Ooh. How is the weather down under? I'm freezing in Germany. Well, it's actually kind of okay today. We are having a bit of a rainy day, so it's not crazy hot today. But we have had a couple of 35-degree days, so nice and hot. Yeah, no, it's nice that it's cooled down a little bit today because of rain. Because I don't have air conditioning in my house, and we are going into the middle of summer. So I do have a fan blowing at me. I'm hoping that doesn't give too much background noise on my my microphone. But yeah, no. I think I prefer cold over hot. Why did I move to Australia? I don't know. But yeah, it is too hot. Anyway, so the pit controllers, I'm no longer using those objects that I have created. I've actually embedded the logic in here, and the reason I've done that mostly is because I tweaked the logic so much to what I wanted to do here. It didn't make sense to have a general purpose pit controller. I deleted the angular one, but I do still have the linear one because I'm using that for my height control of my player character. But I probably will be moving that same logic into the what is it called? Into the raycast body. That's the word I was looking for. Into that implementation, and also not using the controller anymore. It's nice to have some generic logic so that you can use it everywhere, but I'm tweaking so many things to the specifics of a certain area. It just doesn't make sense. Also, I'm just using PD controllers, not bits. I found that the Intrigo grain just too hard to tweak with everything that we're doing. So left that out. All right. Anyway, going to the actual logic in process. So there's some comments in here that we're going to go over that I'm slowly going to start addressing as we build more. But our physics process is obviously the part that controls our movement of our hands. Obviously, there's some checks here. First of all, if I've just got it disabled, freeze is true. It's actually going to do nothing at that point. So basically, the assumption is that we are controlling the hand from outside. The place where I'm actually using that is where I'm just using the collision hands as a placeholder. But generally speaking, don't think that is very useful. Now we do have a target override here, which currently is not being used, but the target override we will start looking at some point, because the idea there is that instead of it following the hand position, we are going to follow something else. And in this case, that's often like if you grab a static object and you want the hand to just be locked to that static object, then you can have that target override work. But right now we're not using that anywhere, and that logic might change because it's an inheritance from XTools 1, and there's things that are changing enough here now that I'm not quite sure if that is the way that I want to keep that working. If we do not have a target override, I'm actually going to check the hand tracker that we said. So let's actually re-enable this, by the way, before I forget. So yes, I do want hand tracking. Thank you very much. So logic here actually checks if we have hand tracking, and if we do, we use that. And if we don't have hand tracking, and with hand track in this case, I'm not talking about that I'm tracking my hand through my controller. Hand track, I mean I'm actually tracking my hand, right? Optical hand tracking. If we have that, then that's the data that we use, and that data has some issues, which is interesting. Now, if I have a controller, and I have the hand tracking extension enabled, and we have inferred hand tracking, which TeamVR does, then we still use the hand tracking API and positioning. But for runtimes that don't, or if that is turned off, like we tested just a minute ago, then I am actually using the controller tracking. So that is the logic that we have over here, where I simply switch between, am I using the normal hand tracker, or am I using the nothing interesting, or am I using the controller tracking? And if I'm using the controller tracking, I am actually applying an offset, because in this case, and this is something that I want to change actually, but in here I have a fallback. Where is that being? Did we? No, we have a fallback. Where are you, fallback? Is it a separate part? No, it's fallback. Oh, it's collapsed. So here we have a fallback where we say, well, we're actually either going to use the palm pose or the grip pose. Thank you very much. And then we have an offset that we can apply. Now, there's a little bit more that needs to happen here. Specifically, if we are using the grip pose, I want to, and I've done this in XtraTools 1 already, but I need to port that to XtraTools 2. I need to make sure that we adjust the orientation of this pose that we get back, because every controller, and this is the way that the specification works, right? If I'm holding my controller horizontally like this, then I have the body where I'm gripping the controller. So the grip pose is in the middle of that, or generally it's located where the button is. That again is another thing that that different controllers can decide to do slightly differently. But the grip pose is also rotated to conform to the grip. And who do I use? Who can I safely grab without giving away things I'm not supposed to give away? That's a controller from Pico. When I put those together, those are, they're, you guys can't see because it's the wrong way around. They are slightly different. Not much, but they differ by about 5 degrees. I'm hoping that I'm holding them both, and whether you guys can see that. Yeah, that angle isn't the same. So the orientation of the grip pose isn't the same between those two controllers. And it gets worse. If I'm using a Pico controller on a Pico headset, and I'm using, I have a nice Pico, and I don't have it in here right now, but I have an interaction profile for Pico. Then I can detect like, hey, Pico controller is being used, so my Pico controller interaction profile is being used, and therefore the rotation is, I don't know, 60 degrees or something. I don't know them off the top of my head, but it's in that order. So I need to adjust my my grip pose by that much to get my horizontal angle so that I can place my hand correctly. However, if I do not have the Pico controller in my overview, and it falls back to the touch controller, which, by the way, on the Pico it doesn't do that. It should, but it doesn't. But it does do it when you are using Steam Link. Um, it'll actually give you the rotation of the Pico correctly, so still 60 degrees. While I've now said, oh, but if I'm using a touch controller, it's not 60 degrees, it's 50 degrees. And I'm off by 10 degrees. I don't know if it's those angles, but it's a problem. Anyway, that's the problem that we have in Extra Tools 1, and problem here. But it is also why I am defaulting to the palm pose. But we do need to have some extra logic here that says, hey, what are we using? Which pose are we using? And put some logic there. Now, here's another problem with this. I can name this anything that I want because it's an action. So one of the things that I'm missing right now that we haven't exposed yet is to get information, based on the interaction profile that is currently bound to the controller, is which actions are bound to what inputs. It's still something I want to add to Godot that we can actually see that information, because I really want to say, hey, do I have a palm pose bound? Yes, I have a palm pose bound. Cool. What action is it bound to? Oh, it's bound to an action called palm_pose. That's the action that I want to use instead of second guessing it. So lots of room for improvement. Anyway, going way off topic here, but there's that as a fallback. Now, with that all done, we have now figured out where our controller is supposed to be. We are now converting that to our global space based on the collision hands parent, which we assume is an XOR origin point. And we now have our target. So in this case, we have our override target. We might lose that functionality, but fine. And in this case, we have our actual track target. So we place our ghost mesh on that location. Go. Sweet. Very happy about that. But now we are going to do some extra logic. The first thing is, if our mode is set to teleport, we freeze our object and we just put it there. So now our actual hand mesh that we display and our ghost mesh, they're going to be at the same location. Sweet. But if we have none of all that, we are actually going to apply our physics movement. There's one small little extra thing, is that we check how far away are we currently from where we want to be. And if that is beyond the teleport bases, we are again going to say, like, okay, we're just going to place it there. So this is the idea, like, it's a kind of safeguard that if the person has teleported, that we don't try and make the hands move from where I was before the teleport to where I am now, because that would be dumb. Although there's another solution coming once we actually implement teleport there, to make sure that we don't rely. This is kind of like a catch-all. If it all goes wrong, let's fix it. But it's also, if I'm stuck behind something and somehow I've moved way beyond that place, then at some point it's going to stop trying to get the hand there, and it's just going to go, okay, the hand's now in this new place. Thanks for coming. In that situation, we also have an option to say, well, if that happens, whatever I was holding, drop it. Doesn't make sense for that to move along. So this is just a safeguard. However, if we get past that point, well, there's some remarks here that I want to start looking into, like, okay, improvements. But the most important thing is, if we're frozen, we're going to unfreeze, we're going to reset our velocity, and now we're going to actually start tracking our hands. So that's when we come from a situation where we were frozen, and we're now going to start doing our tracking. We unfreeze and we do. Normally, we should be unfrozen. We do our normal things. This, again, is just to preempt something that I think I want to do. Is that we might be applying our forces to the actual object that we're holding instead of our hands themselves. For now, we're applying it to ourselves, and I've just written that. So the first thing that we're going to do is, and this is new, I wasn't doing this before, we are getting our velocity information of our parent body. So when we start up, we are actually going down the tree. So we're going to have our left collision hand, and we're going to find our origin, and then we find, hey, our character body. We now know that our parent body is a character body. And as our character body moves around, we want to apply that movement to our hands as well, so that we don't have the hands sort of catching up to body movement. That was a problem that we were trying to solve, that we had still during our last stream, and that I solved while we were between streams. Except then, of course, that I now found out physical movement is going away. It's giving problems. This is assuming that we both have logic on this is a rigid body. So for whatever reason, this is kind of looking forward to that we would also be able to use our hands if we're not using our player controller, but we're using a static rig. So vehicle, for instance, I'm sitting in a car, I have a vehicle body, then I have a XR origin and an XR camera, got it set up for seated mode. We're then not using our player body, we're not using our rigid raycast body logic, we're not using our locomotion logic, we're not using our physical movement logic. All gets thrown out. That is not applicable when we are doing a rigid body. But I do want this logic to work, that I could have my hands tracked while in the car, so I can use my steering wheel, or don't know if anybody's played like VTOL VR, where you can interact with everything that's in the cockpit. We should still be able to use our collision hands in those situations. We want to make sure that our collision hands move along with our movement of the thing that we're in. So in this case, we're getting our linear and angular velocity from the rigid body directly. We're good, happy. If it's a character body, oh, now we have a problem. Character body, velocity, easy. We can just get the velocity of the character body. Sweet. But we're not tracking our angular velocity. So I'm actually calculating my angular velocity here. And that was a missing ingredient that I had for a long time. Still doesn't work properly in XRTools 1, now working properly in XRTools 2. Mainly because I didn't know about the existence of that little formula and how that works, and how angular velocity was actually defined. So the problem that we have with this bit of code, so this is the part that we're going to be working on in a minute, is this is the combined changes to velocity of our physical movement and our virtual movement. I'm actually slightly surprised by it. No, I'm not, because we are taking the linear velocity here, and the linear velocity actually does not include the physical movement. But our angular velocity does. And I think that's also where our answer lies, where we are going to improve how this works. Because we're going to make sure that we get that from somewhere. Okay. So yeah, I think that probably our linear velocity is fine. It is purely our angular velocity that is the combination of the two. All right. Anyway, we're going to be looking at that in a second. I just want to explain the rest of the changes that I've made over the couple of days, especially for people who are watching this as a VOD and have looked at the previous couple of streams. I want to sort of catch up what we've been doing. So we're first going to apply our linear motion with a PD controller. And I've now combined this in here. So originally, what we did is we take our delta movement, how much are we supposed to move between where we are now and where we are going. And we look at the linear velocity, which normally was calculated inside of the PID controller. Then we discovered, like, no, it's actually much better to use the linear velocity that we already have, which is negated. So we are trying to have a dampening force on our velocity. And ignoring this bit, taking just those two into account, we apply our proportional gain to our delta movement, and we are applying our linear derivative gain to our linear velocity. Adding those two together, here I'm just, again, preparing for when we might pick things up, that we actually adjust it by mass. I want to do a restriction at some point, but I'm leaving that out for now. And then finally, we do and apply those forces. So that is the original logic. But what I now added, and this bit is a two-part bit, one part that now works and one part that doesn't. The first is I'm adding our parent velocity into our velocity damper. So in this case, we take our parent velocity and we subtract our own velocity to make sure that that external velocity that is now being added is also applied in this logic, and actually does the opposite of dampening. It actually accelerates towards that velocity. So for linear movement, working perfectly. But then when we rotate, the thing is, our hand is not in the center of our body. Our hand is here. So when I move, or when I rotate, well, yeah, if I rotate, we can see that our hand moves as well, right? So as my body rotates, I need to account for the fact that I've moved my hand from here to there. So that movement, that acceleration, or that velocity that is created there, I need to account for that movement. And that's what we're doing here. So here we are, well, this is a little bit overkill because that reconstructs the quad that we had over here, but I'm trying to sort of isolate this as blocks. Yeah, I'm losing a little bit of performance there, but maybe at some point I'll make that one, just globe, or, a script variable, and not hide it inside of this block. And we don't have to then go and reverse these steps, but it's easy enough. And I needed to calculate the length here as well anyway to see if we've actually turned. So I'm only doing this if we've actually had a rotation. But yeah, that is the rotation that we have. I'm expressing it as a quaternion. I am then calculating what our current local, well, actually in global space, but local to the parent body, where my hand is in space. That's my was position. So from my body to where my hand is, that vector. Now I turn, actually let's turn the other way so that you guys can see. And now my new position is that vector, because I've now applied my quaternion to my previous position. So that's my previous position. Now I apply my quaternion. Now I have that location. I've got that to that. Gives me a delta. That is how much I've moved in this frame. And I obviously need to divide that by delta to get a velocity in meters per second. So that velocity that's created by that turn, I am adding that into my linear velocity calculation, and therefore I'm applying that movement to my hand. I'm applying the right force to create that movement of my hand, and that's why when I was turning my body, my hand was following. Now the problem is, like I said, when I'm turning virtually, so turning with my joystick, I'm still sitting like this. My hand isn't moving physically. So my turn of my body in the virtual world is the amount that I need to adjust it by. If I turn in real life and I'm doing this, not only do I turn, but my tracking data now reflects the new location. So if I am also adding this, I am getting my movement because my tracking changes, and I'm getting my movement because I'm double accounting for that in the actual turn. That's our bug here. Gets funny. Long story short, we're going to have to make sure that this calculation only includes the virtual rotation. It does not include the physical rotation. And again, as far as I know, that doesn't do there. doesn't matter. Now, when we look a little bit further, so that's everything for our linear motion. We're doing the same thing for our angular motion. Here in this case, I am looking how much in my tracking data do I need to rotate my hand, converting that to a cotillon. Now, this is all stuff that we did on stream last time to explain this, but I'm now getting my axes, I'm getting my angle. That gives me my axis angle velocity. Again, same thing. I'm taking my rotational velocity as my angular velocity, and then I'm taking that rotation that I've calculated for my parent body, which would now double up the rotation of tracking. So again, it's not just the positioning; it's also the rotation that I'm overcorrecting. Although you see that a little bit less. But then there's this extra little bit where I'm getting that rotation of my player body in the local space of my player body, and I need to adjust that to the local space of my hand so that I get the correct rotational force on my hand. So that's why we have that extra little bit there. All right, so we end up with our delta axis angle. We end up with our rotational velocity, and then it's the same as with the linear. Our delta axis angle, we multiply with the rotational or the proportional gain. Our velocity, we multiply with the derivative gain. Add the stuff together. Got some remarks here. If we do start applying this to the picked up object, we need to take inertia into account because we can't use our set inertia to 0 trick anymore. We actually need to apply inertia correctly. I also, again, have a restriction on maximum torque that I might want to do. And then we are applying that torque to move the hand. So that's a lot of talking. And then finally, I am storing my wall spaces of my parent body, which actually needs a... Oops. Although that is the bit that I right now want to change. So what I really want to get to is instead of doing this all here, where I'm looking at what was my rotation last frame, what is my parent's body rotation now, take the difference. I actually want to get that information from the correct spot. I really want to have a proper angular velocity for my character body that is only taking the virtual movement into account. Now, the easy way to do that would be to put a script on character body and measure it there, because then I would have direct access to it. But now I get a dependency that this character body needs to have additional logic. And we're trying to move away in XRTools as far as this part of it is concerned. Can't really do it for the construct and staging system, but definitely for the character system, we want this additive approach where if I have a character body that's just a normal character body, users can do whatever scripting they want on it. But then I've got these additional things that help out. So there's two ways that we can deal with this. One is we can actually have the physical movement handler provide us with how much rotation we have applied there and store that so that we can subtract that from the rotation here. That's option one. The other option that we have is that we have our locomotion handler provide our angular velocity. And I think I'm going to go for that solution because that is really where all the movement happens. The downside of that one is that if someone is using a character body and is using the collision hands and is using the physical movement handler, but has decided to implement their own logic for movement, we are not getting the proper angular velocity. We don't have access to that. So that is a bit of a problem. And I've actually had that problem with a couple of other things. You can see actually in our locomotion handler, I've got some callback things. So I've got a register on floor callback because in this case, I've got my raycast body that is now overriding my on floor logic, and I have to tell locomotion handler, don't use the on floor of character body, use the on floor of the raycast body. So I might have to do something with that here as well. And I'm not completely sure what the nice solution is here. What is the best solution for this? How are we going to extract those two? Oh. Well, one way that we could potentially do it. Yeah, that might work. We can actually track the rotation delta of our origin point. Yeah, that'll work. Because when we physically move, so let's say that I move physically like this, 45 degrees. What we're doing behind the scenes is we are now rotating our character body by 45 degrees, the 45 degrees that we don't want. And now we're rotating the X or origin point 45 degrees negative. Now the origin point in global space might have moved around whatever distance it is from the character body, but purely orientation-wise, it is now back to not having rotated. If I now have virtual movement, virtual rotation, my character body moves, let's say another 20 degrees, and my origin rotates 20 degrees with it. It also rotates around an orbit, but I don't care about that. I only care about the rotation itself. So if we take the logic that we have right now, but instead of applying this to our parent body, we are applying this to our origin. That should work. And as far as I know, origin is mandatory here. Have I already got that? So we got a parent buddy. We are not getting our origin. Collision hand, yep. Collision parent, yep. Okay, am I giving a warning? No, that's not it. Where are you? Surely I've got a warning in here. No, I don't. So we're not even forcing our collision hands to be part of an origin node, which kind of makes sense because we're... Oh, yeah. We don't actually care because where's my logic here? Where's my logic? Physics process. It's actually staring us right in the face. Oh, it's getting the global transform of our parent. Right. Position this. We can just do it on our parent node for this. And we already have it. Yes. Oh, this is cool. If this works, this is so cool. Calculate a parent's angular velocity. So what we're going to do instead is, yeah, so here, our character body also includes our physical movements, and we would count. Okay, I just want that as a remark here. Of course, I need to zoom in so that I can actually read this. Perfect. So let's go and duplicate this. Let's go and comment that out. And instead, parent transform. Let's go and just calculate it over here so that we just always have it. The few times that we would calculate that when we don't need it, who cares? So just parent, get it. Thank you for coming. So this is going to be parent transform. Parent transfer. That is a global parent transform, isn't it? Yes, it is. So we can just grab the basis here. Cool. And then obviously here, hey, we no longer need that fix. So let's go and do that. Let's go and do that. And instead we say was parent basis is parent transform dot basis. Ha! If this works, that would be an awesome simple fix, and that would work regardless of where the physical movement is coming from. But we are correctly isolating it. Why is it not starting? Oh, because of course we waited too long, and Steam Link stopped working again. My own fault. You know, I can't blame Steam Link for this. I can't blame Meta for this. This is just, hey, headset goes to sleep, network connection gets lost. Kind of normal, right? Although it would have been really nice because it does try to restart Steam Link. And once again, this is the other thing. From time to time, it tries to restart it. We try to reconnect, and then it says, hey, my session here is still the old session ID, which I'm trying to reconnect to. Go away. But there's now a new session, and it doesn't like that. I'm pretty sure there would be a better way for it to automatically reconnect. Anyway, hello, we're back. Let's see if this works. So our movement here, we're happy with. Our movement like this, we are happy with. And we fixed it. Ah! How awesome is that? Because just thinking through the way that everything works, and because of the way that we're tracking, you know, it makes sense. We use the untracked part of this. Yeah, I am stoked by that because yeah, that now means we are purely applying virtual movement here. And again, the thing is, you know, it's very important to realize because of the way that I have implemented the physical movement, and this is really important. So when we look at our physical movement handler, the important ingredient here is that if I go to a physics process and we look at the movement here, where are you? I'm too far. Here we go. We are doing a move and collide, and move and collide does not affect the linear velocity of our character body. only the logic that we have in our locomotion handler, where when we look at physics process, we are doing a move and slide. That is changing the character velocity. That is why we can get away with this. And again, the most important thing for me is if our user decides to use a character body, decides to use the physical movement handler together with an origin, wants to use the collision hands, but decides not to use our locomotion handler, but implements their own locomotion logic, our collision hand should still work. As long as they use move and collide to actually move the character body, it should apply that logic correctly. Cool. Awesome. All right. Now, in a teleport situation, we are going to have to look at, okay, how does that work? Now, there's one more thing to try. This is going to be interesting to see if this messes things up. On our left hand, there is a direct movement controller. We are right now have a rotation speed of 90 degrees per second, and it's smooth. So I've added this thing called a rotation step angle, so we can set that, say, to 5 degrees. That means that instead of a continuous movement, we are now moving in steps of 5. So every time that our movement, so we move 1 degree, 2 degrees, we're not actually moving. We suddenly hit 5 degrees. Now we move. And 6, 7, 8, 9, 10 degrees, we move. So that gives that stepped rotation that is important to combat motion sickness. The big question is that going to screw up our hand logic? If you want to try. Oh, that reminds me, I, of course, forgot to. Yeah. I really should control that from inside the headset, I think. I think I need like a little menu or something on my hand that I can control what you guys are seeing with. Oh. Okay. Sorry, guys. I'm just going to okay, so that is definitely not happy when it comes to hand positions. I don't really think there's much you can do about that, other than yeah. I hate stepped rotation. Let's go back to. Oh, Jonathan, how you going? Yeah, it's going good over here. Having fun. Trying to figure out all this stuff. So yeah, back to normal. I just wanted to prove that what I was seeing actually works. So, oh, did that not save? That did not save. Of course, that didn't save. Back to 0. Godot, you're supposed to save when I press play, but I guess it's because that field hadn't lost focus yet. It does not do that. Come on. I can't see my mouse. Oh, this is so annoying. Okay, I need to do this. I can't wait until I can use other. Okay, so that now works. Very cool. Sweet. And if I move my head, no weird things. Okay. So the question now is. Yeah, that works. So So the thing, of course, is that when we let's double this. I just want to see whether it's just that, So now we've got fast rotation, and we can see that our hands. Oh, you guys can't. So now we got faster rotations, but we have our hand still nicely staying there. Actually, that's actually a good one. Do you guys see this correctly? Or because I've got the stabilized camera, no, that nicely stays where it's supposed to be. So that part of it works. Oh yeah, that's because I only stabilize my my physical movement. That's right. Okay. So what is it about stepped? I think it's just because oh, of course. Would it is that maybe it? The thing that I'm wondering about is one of the problems that we have here, but no, that wouldn't. We're not applying the delta until the end. Because obviously a basis can only store up to 360-degree turn. And seeing we now have a 5-degree turn in one frame, because that's obviously what happens with step rotation. Yeah. Our 5-degree turn in one frame when we're running 90 frames per second. So that is 5 times 90 is 450 degrees per second turn. Yeah, that's more than 360. So it might be that that is why it is throwing up. However, yeah, I've got a feeling that when we apply that much of a rotational force, well, we're going back to where we were here. I don't know. Either we're overcompensating for the, because of course we're basing it on our derivative gain. So obviously if our derivative gain is too high, especially with such a high velocity of turn, yeah, that might cause a problem. That's the downside with using constants in this case. So that's, I think what is happening here is that because we're having such a massive increase in velocity for one frame, that it screws up. So I don't think that's a whole lot we can do about that. I'm going to leave that for a problem for another day. I might just put a remark here. Hand velocity, rotation. To do if stepped rotation is used, we overpower. Possibly. So we're going to have to detect that. And one of the ways that we can obviously do that is constraining the angle and saying, hey, if it's more than, let's say that if it's more than 180 degrees per second that we are turning, so if angle is more than pi, then let's not do this. Let's slow down. Or maybe even say, well, you know what? We're going to restrict this and say, well, we're not going to do it by that much. We're going to actually make it a little bit less. Maybe. The other possibility here is, I don't think that's a problem with the 5-degree turn. I think because there is some logic that I haven't applied yet, that if our rotation decides to go, instead of 5 degrees to the right, it is going 355 degrees to the left, that we need to find a shorter angle. I don't know. That's something I still need to look into. I still need to have a look at, okay, is there something in our calculation here when we get our Cartesian where we need to actually adjust our Cartesian to go into the right direction? And with that, I am also thinking that this is logic that I might actually want to put into a helper function, and possibly not store axis angle, but actually store the multiplication of that. That's for later, I think. But yeah, I really want to have a function where I just take a basis and it outputs an axis angle value, or a velocity in this case. And just as a helper. Yeah, I think that's something that I want to do at some point. And then I can put that logic in there because we've got it here and we're repeating it over here. So yeah. All right. I'm happy actually with that part. Now, again, the step stuff doesn't work right, but I'm so happy that we found the solution for that real quick. I don't want to have a search for this because we're doing stuff with this a few times. But obviously, we don't want that. But now we want to go over here. And we want to say var parents node3d is parents. You would say parents. Oops. Parent global basis. Yep, there we go. Okay. Same here. So am I already getting a parent here? No. Parent is got parents. Go to type pass. There we go. If parents. And then it becomes parent. There you go. No 3. There you go. All right. So that's not separate from that. Very good. There, we're just applying it. Perfect. And there we're sitting. In this case, it's safe because parent transform will be set if we had a parent. And then in this case, I actually want to make that safer. So let's make that there, and actually we can now where were we? Here was first applying it. So no, I want to just always set it. Why not? Our parent node 3D is get parent. I think get parent applies a node 3D, right? No, it gets a node. So yeah, it's good that we do that. If parents, again, it should always have a parent. It's really only if we would use this as a tool script, but we already disabling it. Well, no, that's only in the editor. So you would never start that script in isolation. So this is really just me being absolutely paranoid. There is really no reason to check if we have a parent here. It's pretty much guaranteed that we have a parent. But it's nicer than getting a random error in your debug log when somehow this code gets run when we don't have a parent. It really shouldn't, but you never know. Yeah, I'm definitely being paranoid here. Anyway, better safe than sorry. So that is all that cleaned up. So yeah, we purely have the step rotation where we might want to go and limit that angle. So yeah, maybe at some point I'll clamp it. But I'm gonna leave that as a problem for another day. Yeah. So all of this is now working the way that I want it to. Now the thing that I am wondering about is when we look at the logic that we're currently doing around picking stuff up. And this is another reason why I might want to put some of this into helper functions. Oh, this is actually, now that I think of it, probably the better way to do it. However, in our pickup logic, what we are currently doing is when we pick something up, figure out what the grab point is, figure out what the offset is. And this is that thing that I talked about where I'm just, excuse me, I'm forcing the collision hand to be where my grab point is. So I'm placing my hand onto the object that I'm picking up. Now I'm adding a joint there to link those two together so that they are now moving in unison. If I move my hand, I'm moving the thing that the hand has picked up. And what I'm doing here, let's see. Yeah, so that's my original. Grab and with that, I also do that. Yeah, so that's my raycast thingy. Something to improve that. So yeah, so I'm putting my collision hand on the object that I'm picking up at the place where I'm picking it up. And then here, I'm now putting my hand mesh, which is a child object. I am moving that to where my hand was. So my whole collision hand is actually now on the box, but my real hand is still where I started. And then I'm tweeting that hand mesh, boom, to the 0 location. While at the same time, because my physical hand is still here, my collision hand is now on the box, and I'm pulling the collision hand to where my actual hand location is. So those two sort of meet in the middle and then go back. So that's giving that smooth hand effect. All right. So we're doing that if we have a collision hand. If we're using a normal XR controller, what am I doing now? I'm actually using a remote transform. So that's the other thing that I did here. Even though I haven't really done stuff to further test this, and I might at some point. I'm not quite sure yet if I'm keeping that. But if I'm not using a collision hand, but I'm using a normal XR controller with a mesh, at that point in time, I'm just using a remote transform, and they move in unison. So I'm not doing fancy physics here. I think actually the picked up object is frozen. Yep, it's frozen. So that I can move it myself. This is the old XR Tools 1 approach of doing things. And at some point we'll do some more. But we're now gonna concentrate on this, where we're doing our collision hand logic. Now, this is where I'm thinking we can turn around how we do this. Wow, this is actually really dirty doing it this way, because I'm making assumptions here on how the collision hand works. I am accessing a private variable because it's just a convention that we underscore those. It's not enforced. Yeah, this is actually a little dirty. I'll admit that. Um, but I'm suddenly realizing we can do this much more nice. Assuming that what I've had in my head works. And the thing that I have had in my head is that when we pick up an object, instead of applying the forces to the collision hand, and with that moving the joined object, is that we disable the logic on the collision hand. Which you kind of have. We could go further with this, that we say if we have a target override, doesn't just mean that we are positioning it there, but we're actually doing a whole frozen thing. We're very tempted of going there. I'm just saying, okay, if I've overwritten my target, I am not going to do any of this. I'm going to treat it as a fixed thing, because I have said place the hand here. Don't care about tracking. Place the hand here. So very tempted of doing that. It's just saying, got a target override, freeze, place, end the story. Don't do collisions on the hand. Instead, we are going to move the object. And the nice thing about that is that obviously we're going to have to replicate this logic, but now in our pickup function to apply these forces directly to the object that we've picked up. But suddenly, I no longer need that overrule logic. If we look at the pickup function, it is no longer going to care whether this is a collision hand. Well, I still want to know that it's a collision hand because I need to do my target override. Jonathan, how do you mean careful of the pivot points? Which pivot points in this case? Because I'm not using pivot points. Anyway, or do you mean that applying the forces to where the hand has picked up instead of to the center of the hand? That is actually, or center of the object that I picked up. That's actually a good one. We need to make sure that that offset is taken care of. That's actually a good one. We need to make sure that offset is respected. Because the thing that I'm thinking about right now just as a shortcut to see if this works, I actually want to just abuse the logic that we currently have in the collision hand and just make it work on the picked up object. But I think we're not going to get around huh. Yeah. Because I wanted to think about, how can we quickly test this without rewriting everything? But I think we might not have an option other than moving the code or duplicating the code in this way. Though one of the nice things of duplicating the code is that we can tweak the numbers further. Okay. Yeah, I think this means that we're gonna have to do some restructuring and actually put the code where it belongs. Okay, I think that is perfect. So this solves a whole bunch of things. First, it solves that the code is actually going to be similar whether we're using collision hands or whether we're using a controller directly. When we're using a controller directly, we are not going to know where the hand mesh is. That is not a problem that I'm going to solve today or maybe anytime soon, because I really want people who are using extra tools to use the collision hand. But if someone doesn't and does want to do the pickup logic, then perfect. And they're going to have to, excuse me, they're going to have to do their own logic to position, the hand model correctly. There, we can handle that with signals, right? We can make sure that in the case that it's a normal controller that picks up, we still do all the logic that we need to do. But excuse me. But then the hand positioning, because we don't know the hand object, that's something that the person needs to control. But we can send out signals here that they can hook to, and that will work. And thanks for coming. All good. Again, I am not going to concentrate on that mode much. However, it means that whether we have a collision hand or whether we have a extra controller, because we're now applying the forces to the picked up object, we actually don't need to do this approach. We can now use the same approach and apply forces to the picked up object and have it collide with things. The only thing that I'm wondering about is when we look at something like this, would we still want to offer the option to a user that they don't want physics on the picked up object, they just want to move it around. And if you move it through a wall, then you move it through a wall. Who cares? That is a hard one to think of. The other thing, of course, is in this situation where we are moving the object, we are not going to do collisions on the hand itself. The hand is just going to be on the object. We're going to assume that, yeah. So if I move my hand slightly through the wall, the object is nicely going to sit on the wall. Maybe we will do some sort of object that we add as a temporary collision shape to the thing that we picked up, just to create that. But I am not too worried about that. It's not something where I'm going like, hey, that is very important. However, it now means like, cool, I have picked something up. When I pick it up, I am now going to make sure that I am going to apply my forces to the picked up object. Unless it's a static body. When I pick up a static body, which is currently not in the code here, is now all of a sudden, I still want to set my target to where I've picked this up. And whether that means that I've got to create a temporary node or whatever, I don't care. But I'm setting my target so that my hand shows up on that object. And in this case, on a static body, I'm not moving the static body. I am moving the hand or placing the hand somewhere. And now I am in a situation where I will apply forces to the player body instead of to the hand or to the picked up object. So all of a sudden, all the physics logic is going to move into the pickup logic. And the other thing that's going to be really interesting is how is this going to affect two-handed stuff? Because that's the other thing that is a problem here, is if both hands have picked up the object, I should only apply forces once. As far as the parent rotation is concerned. Because else we're going to be doubling up on those. That is solvable. That is definitely solvable. If I think I'm already doing that. Yeah. Because I've got my pickup handlers. I can detect whether I am. Oh, I've already done that. If I'm primary. So I'm already checking if I'm the primary pickup. And that means that only on the primary pickup we are applying our parent body logic. Yeah, that's gonna be yeah. Yes. Yes, 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 yes. Okay. This is going to be a lot of work. Let's see how far we can get in today. That does mean that I do want to do one thing before we continue, and I don't actually care in this case about any changes here. There might not be any. Oh, only on what did I? Yeah. Did I accidentally check it in with that set to false on the other one? That will be stupid. Really? Um. The. Eh. We're eventually gonna merge this anyway, so we'll fix it back. Whatever. So I actually want to go and rename this to fix actually if yeah branch minus m fix parents location. It's at dots. So, physical location was double. Okay. Push origin fix parents location. Yeah. All right, and before I continue on those, I'm just going to quickly raise okay, let's see. So demo, no. Improve spectator cameras. There we go. Compare and pull. There we go. So just going to create the PRs on my repo. Just doing that in the background. Oh, what? No, that's not the one. What you did that for? I said, this one. Okay. Why does it not do that? So annoying. New pull workout. So it'll look like this then. Different. Yep. Here we go. Now it's correct. Okay. Perfect. Makes improvements to the spectator camera. So this is going to be yeah. Added stabilized camera to the improved. Spectator. Stabilized. Stabilized. Sorry, guys, I just want to do a little bit of housekeeping here off camera just to make sure that this is all looking good. So this is now 59. That means that's pull requests, new pull request to demo, to demo. Okay, that's cool. Create pull request demo for 59. Okay, that one I'm not going to put on a milestone. And I actually want this to be on here. Oh, that's not the right one. Sorry, guys. I'm just making sure that things are where I want them to be. Oh, what the heck? Okay. All right. What else? Pull request, new pull request for our fixed parent rotation. Creates, so that's going to be on both of those. All right, assign, that's a, oops, bug fix, fix issue where physically rotating your body with double up hand movement. Only apply virtual rotation. You are okay, cool. Great. I can start cleaning it up later and then merge those things. All right, sweet. So I don't really care about the demo changes for that. That's just a fix. That's in there. I just didn't want to have that mixed into the logic that we're going to do here, because we might find out that what I'm planning to do here doesn't work, and then obviously I don't want to lose our fix. So, cool. All right, this is going to take a while to build, I think. But I'm actually very interested, or very positive that this will actually do what it should do. What are we doing here? We've got process. Okay, so that is just to let go and pick up. Sweet. That's exactly what we want to do. Now, obviously, we want to make sure that our drop logic eventually gets changed, but that is not something to worry about. So we are going to get a physics thing here, which is really cool. All right, sweet. Okay. All right. Now, as I said, I eventually want to go and combine our pickup logic. Well, indeed. So static we'll do later, but I think with what we're doing right now, suddenly grabbing static objects becomes much easier. Although there we do need to have some more control, because we don't want to be able to just grab any static object. No, we're not Spider-Man. We don't want to be able to climb up any possible wall. But again, that's a problem for later. Another problem for later is making this work for both XR controller and collision hand controller. Or is it? Or are we going to do that right away? Because we're not going to care about that. We're not even going to do the remote transform there. Okay. Sorry, I just need to. Yeah, I think I am going to implement this for the collision hand situation first. And I'm just going to make a note here. To do. You know, these to-dos are going to be here for years, and I'm going to completely forget about them. The way we now make this work for XR collision and can also be applied for for a normal for XR controller. We just don't have the target override logic. But we can send a signal that the user can. So that is for later when we want to do it for both. And at that point in time, you know, because that's the other thing right now, we don't know that for physics bones. Because that's the other thing. I need to transfer this from my other demo. A little while on stream, I actually made a complete ragdoll. So just like we have that thing hanging off of here, I actually have a ragdoll hanging off of a thing. You can grab the ragdoll, and actually I added some at some point that you could pick it up and do fun things with it. So yeah, we'll eventually figure out something with a nice little, yeah, not to worry about that right now. Okay, so so in this case, whether it's a rigid body or a physical bone, the logic is the same. That's really cool. Okay. We are going to seriously change these things, so I'm not going to worry about what I break. But before we start with that, I am first going to do a bit of cleanup on the collision hand. The first thing that we need to do is we need to do our target override properly. Now, that's cool. I already have that in. Sweet. Oh man, that is so cool. I am so happy about that. So there is an add target override here where I can specify a target and I can specify an offset. And this is built that in theory, I could have multiple things overriding my target. In reality, it will always be one, really. But you know, there is a possibility that there are more. So there's a priority. If we have a target override, we are going to grab the one with the highest priority. So what we're going to see here is we're going to, oh yeah, we're going to remove anything that we have currently, which is really cool. If we already have this target, we're going to remove, we're going to assume that we have a different offset of priority. And we're going to insert that. And then eventually, you know, if we have something modified, so in this case, we're always set it, but sure. This is some code that I copied from Malcolm, and he's a little bit overzealous here. And I get it because it's sort of a pattern, which I like. I like following patterns. So in the case of removing, we just remove, and then if modified, target. Here, you know, we just have the same thing, but if we have an insert, we modify it. Cool. And the insert itself, just inserts it. Oh, and we are ordering it by priority. So automatically, the one with the highest priority is, I'm guessing, at the top. Probably. Add target override. Very cool. So in our update target, we are going to say, if we have something, yeah, we're just grabbing the top one. Ah, that is so cool. Now, the nice thing about this approach is we're not constantly checking what the target is. We're just saying, hey, whenever the list of targets, our target overrides changes, we set our target. Thanks for coming. Now, the thing is that we have an offset. That is what makes me really happy, because that is what is going to make a world of difference. All right. So let's first go into here and say, you know what? If I have a target override, and this is immediately going to mean, no, I want to keep this in there. All right. So we're going to change the way that works. Cool. So we are now just going to do that, but I can go and do that. And what I also want to do in this case is add this in, because that's the one situation where if we later on need it, we don't want to have the was parent basis from 3 minutes ago when we picked something up, and now we're letting it go, and all of a sudden we go through here. Oh, we no longer have a target override. Yay. And suddenly we are doing a comparison between our basis from God knows how long ago and the one that we have right now. So that is why that is important. But in the other places, I haven't done that, and maybe I should. Maybe before any return, I really want to do this. I actually think that is much more clear that we say always before the end, we're going to do that. This is our ready function. I definitely wanted in my ready function. But now I don't care about changing it on mode. That is now overkill. Cool. So I don't care about that. First time, and then now everywhere, whatever. Okay, cool. That also means that we can now do this because we exit early. Cool. Sweet. All right. So if we have a target override, just place it there. So the freeze, again, that just turns off our physics, and we just place it. And we just, we make sure that we update our basis. So we remember that. Cool. Actually, move that there. Let's move that over here. And make sure that also on this return, we do not, because if we enable our collision, then obviously we want to do that. Now, there is a argument. Hold on a sec, I just want to see if this is important. That's all good. Sorry, I got an email about that. Wanted to know whether that was important. Wasn't. Okay. Now, one thing that is interesting is if we have our collision head mode disabled, do we want to apply our target override first? And personally, I think the answer to that should be yes. We have a target override, we're placing it there. Other cases, if it's disabled, I'm going to assume in this case that if you really want to control that, you are not going to use the target override. Okay. So, and actually, that is going to no longer be that. It's just we handle the same. So if we have a target override, boom, apply it. If you're disabled, think that. Okay, cool. We're to our hand tracker. Sweet. Blah, blah, blah. We're going to do our hand tracking logic. Oh, that is actually another crazy thing that I find interesting. Huh. Because I really want my goat smash to work. Okay. Do we though? Yes, we do. Yes, absolutely we do. So, I'm actually thinking. You actually belong here. So we are going to place our ghost mesh where our hand is. So all that logic is true. So yeah, then we do get it. If it's disabled, sorry for coming. We get out of here. Now, in this case, we do all that, sweet. We do all that, sweet. We do all that, sweet. We do all that. So this, I'll edit this stuff out later. No, I'll edit this out now because we're about to change how that works. Sweet. And this is actually false, but I'm not going to worry about that right now. I'm going to leave that coming in. That might come in handy later. Now I think we need to start looking at improving this logic. Now, the first thing that I want to do is I now want to go and put this into a helper function, because we're going to be doing this quite a few times. What is a good place for that helper function? My gut feeling says I want to put it in here. Okay. Yeah. We are just going to put that in here. So let's go and copy all this. Static func bases to these angle. And that's going to take in a bases. No. Rotation. And we're going to do start rotation, bases, end rotation, bases, and it returns a vector 3. Okay. Cool. I didn't. Okay, that is cool. So let's take this all out. And it's going to be return delta axes times delta angle. And we're going to take that out. All right, cool. Start rotation, end rotation. Actually, I want to call that start orientation. And then end orientation. Calculate the axis angle rotation between two orientations. Okay, and obviously this becomes without the parent, this becomes without the parent, this becomes without the parent. There you go. Sweet. Cool. That is what we want. So now, parent angular velocity becomes, that needs to have, what is that called? XR2 helper. XR2 helper dot rotation was 2, in this case, divided by delta. There we go. Sweet. Okay. We have this in some other places. So in this case, we're going to say var delta x's angle free is u from 2. That is not any sort of divide, so we can take all this out. And with that, we're going to go and do this. And we're going to do length. So if we have a rotation or an angular velocity, we do our calculation. Sweet. Cool. And then we apply. All right, that should clean that bit up. Now, I am wondering if we should put all that into a function or if we can just duplicate it. Are we all going to put this into helper functions? That's the other question. Because if we have this, we probably want to do something like ink functions to access nodes. Probably want to put some more things in there at some point. Functions to we call it helper functions. Physics. Okay, that's fine. Hey, Bailey, how you going? Been a while. I hope you're well. Okay. I think in this case, that will be 0, so adding that wouldn't matter. And that would return length 0, so that wouldn't matter either. Oh, cool. You managed to go full-time indie dev. That's nice. So you got a good plan worked out for your game? Okay. So I think that I'm going to want to put this whole thing into a help function. Oh, cool. So. All right, we got that. That's really cool. All right. Static func apply linear. Oh, we actually need that to be offset this time. So we're not going to do it as a central force. We're actually going to do it as an offset force. But that makes it actually easy. Oh, interesting. Teddy was working on AI NPCs a little while ago. That was pretty cool. Air force. Okay. Apply to. Start with that. Yeah, that should always be your rigid body. All right. Let's just go and copy this first. Okay. So. I'm going to rename that to just apply to. Apply to. Okay. So. All right, so is that just a vector 3? I think it will be. So now we can simply say that will be targets. Okay. We don't care about the parent body in this case. All right. The thing here is yeah, I want to have those last. So we're going to start with our proportional gain. Float. We no longer need to call that linear. Our derivative gain. Float. Okay, now I want to do our parent linear velocity. It's going to be vector 3, but it's going to be an optional parameter. Now here, really, do we want to I want to write this out a bit because it becomes unreadable at this point in time. See if it allows me to do that. Not getting any errors, so I'm happy with that. Okay. Then vector 3. That's probably also going to be an offset that we want to add in here. Okay. Ooh, delta is important. I actually want that as the first parameter. Delta float. Apply linear force to our to a rigid based on a target location. All right. I'm not sure if this is the right place to put this, but for now it's okay. Now the other thing that I want to do, actually I'm going to just call this velocity because we're now so to glove position, parent body position, parent global position. Oh, target vector 3. Okay, I actually want to also rename this global targets so that it's absolutely clear that we are expecting global positions. Actually, I'm going to write this even out to global target position so that it's very clear that that's what this is. So that's our rigid body that we're moving. That is where we're moving it to. That's our pit controller. So then optionally, we can correct for parent with the linear, angular, and position, which means that we have that over here now. Cool. And then the only thing that I want to do now is to also add. Okay, so this is going to be interesting. So our global target position is going to be the position that we want this object to move to, and we're actually gonna make this work on the center. Are we, or do we? That would stabilize it, or do we not? This is the problem. Yes. Target offsets. So when I have an object, the cup, and I'm holding it here, and obviously the center of my cup is going to be something over there, and the center of my hand, the point that I'm tracking, is going to be over there. So my target offset is going to be from the center of the cup to where my hand is. And our global target position is going to be our hand. We could adjust our global target position to the center of our cup, or where we want the center of our cup to be, but I'm going to specifically do that, because then in our apply force, we can actually apply to that offset. Now, with apply offset, so we actually want not central, we want the normal one as a position. And the position is the offset of the body origin in global coordinates, which is really fun. So, are we going to do the target offset in global? Yes, we are. Okay, which means that we're now going to get an apply force. And we're going to say that is over here. No, actually, we are going to make that a local offset because that is what we're going to have calculated. We calculate that offset when we pick up. And that's also the offset that we put onto our target override, which means that right now I'm going to want to say target global offset is apply to global bases times target offset. We're going to add that in so we get our global position of our center of our cup because that's what we're applying the force to. We're going to add our global offset so that we're actually where our hand is, and we're going to compare that to our target because our target is going to be the location of our hand, not the location of where we want the cup to be. Very important. And this is where it's going to be important because this is going to define how two-handed stuff will work. Cool. Okay. Velocity is fine. We're not worried about that because we're doing everything in global space, so that's going to be the same. Parent, if we don't have it, it's going to be 0. Parent angular, going to be 0. We do the parent position. Now, this also needs to be, okay, so I'm going to view adjusted position. No. Position is going to be these two together. That can now be that. It's a global position minus parent, so this now becomes original position minus that. You know, it saves one add, but it doesn't really matter. It's just readability here. It's not really local position, but oh yeah, cool. So you're using the AI for interacting with the NPCs, like talking to them or something like that, or you're using the AI just for movement and positioning of the enemies or the NPCs. Don't necessarily need to be enemies, of course. Okay, so angle. So we might need to do that. We got that parent delta movement. That's cool. Target offset. So that now becomes target global offset. Okay. We need that in global space. So even though we're using that all in global space everywhere, I'm still going to send that as the local one because the target offset, that's what we're storing. Okay. All right. So let's go here. Let's go. Oops. XFT helper. Start delta. That's going to be self. We're actually going to be removing that in a minute because we won't be overriding that. Then our global target position, that is target origin. Then our gain is going to be linear proportional gain. Then our derivative gain is going to be linear derivative gain. Then our target offset in this case is going to be, don't need it. Oh, and then I do want our parent things. So we got our parent, then we got our parent angular velocity, and then finally we have our actually that is something that I want to do here. Our parent global position vector 3 is vector 3. Come on, don't side pass. Then obviously that can then be this. And that can be that. All right. So in theory, if we've done everything correct, we can get rid of that. And we now have put that in our helper. Now, maybe we need a physics helper object, which may make sense, but I'm willing to keep it like this for now. Okay. Now, before we continue, that means that I'm probably going to have to restart PBR again. I want to make sure that obviously everything still works. Come on. There we go. Connect. Yay. Okay, back in here. All right, so let's go play. Let's go in. Why is that? Oh, there we go. Okay, that came flying off from off screen. I'm not quite sure why. Which might mean that there is a problem with our startup. But that is working. That is working. I haven't changed my pickup logic, so oops. I didn't mean to change you. That's interesting. That still works. Perfect. All right. Go. Happy, joy. Okay. Sweet. So let's do the same thing for our angular motion and make sure that we have that in our helper function. So apply torque based on target orientation. Okay, apply torque. Okay. Probably going to have some complaints soon. This is going to be target orientation basis. When I check it all in, it's probably going to complain about indentation, but whatever. We'll figure that out eventually. I don't really know what it is supposed to do there. Okay. Oh. All right. So is just going to be applied to. That is going to be our target. That gives that one. It's going to be applied to. There we go. Oh, that should just have been that. Cool. Actually, I want to call that just normal velocity. Velocity. Okay, now we want these two in there. That means that we can take out that bit and that bit. All right. We now have a parent angular velocity, which is a vector 3. First optional. And in this case, we're going to say the length. So if we have that, cool. And this obviously is going to be applied to, and then it is going to be parent global orientation. Basis is basis. I need a comma there. And that is instead of that. Okay. So we got a delta axis, boom, we got a velocity, boom. If we have a parent velocity, then we're going to reorient that and add it to our velocity, sweet. And then if we actually have something to apply, that can actually also be bigger than 0. Length is never going to be smaller than 0. Then we're going to do a proportional gain. We're going to do that. And then we are going to, and obviously that is not part of what we're doing. Now, torque does not need to be localized, interestingly enough. So we are good. Sweet. All right, so we need to make sure that we don't accidentally delete that. Instead, we're doing XR22, upper, apply, delta, self, target the bases. So here we're going to get rotational proportional gain, derivative proportional gain. Now we got a parent angular velocity and our parent bases. Wait. And now we can get rid of all of that in theory. There we go. Alrighty. Let's see if it still works or if we messed things up. All right. This time, you guys are going to see the third person. We didn't have it flying away, so that was a weird thing, probably because I didn't have my headset on. That's still doing, and seeing that we're still working on our old pickup logic, that still works too. Sweet. Happy. That is really, really cool. Next step. Because that means our physics logic is nice and easy to read. I think this is overkill. We're just going to say apply. Angular motion. Obviously, this is still a bit sizable, but that's fine. You know, kind of like that. I'm going to be copying this in a minute. We no longer need we no longer need that. This I'm just, you know, eventually I'm going to remove this, but this is something that I just want to have in place. It's probably something that only is going to be in our applied torque eventually. But yeah, That'll be okay. With all that in place, let's see if we can slowly start moving our pickup function, excuse me, to work differently. So in our pickup, all right, pickup by is primary, very cool. Picked up which, and we have that. Here we go, picked up, blah, blah, blah. Remember our current hand transform. Cool, we need that. That's where our hand currently is. Find our grab point, so we figure out where we're gonna grab. Sweet. So now we have our grab position, so where we actually want to grab our hand. Very cool. Grab position there. Sweet. Okay. And now we get our offsets. What is it about? Transform inverse. And global inverse and transform. Hold on, what am I doing here? And global transfer. Let's see. So this is where our hand physically is. So what we are tracking. But we're going to grab our closest grab point based on where our pickup is, which is, cats, what are you mowing about? Which is where our hand is currently positioned, taking into account collisions and all that sort of stuff. Okay. Based on where our pickup function actually is. What do you want, pussycats? Hello. Yeah, you hear me talking the whole day, and you're wondering, why are you not talking to me? Why are you talking to this monitor? There's no one here but me. Hey, cat. I'm out of snacks. I need to buy you more snackies. I'll feed you later. Not yet. It's not yet food time. You probably want food. You just want attention. One of those. Yeah, you do like that. Me. I need a cat cam. I need a cat cam for you, Puss. I need a cat cam for you. Okay. Cool. So, why is this getting the parent? Right. Right. Okay. Okay. That's why I'm getting that one. Is it? So, still sets. Hold on. Right. I remember now. Yes. So our pickup function. Yeah. So we're getting our hand attachment offset. because that is aligned. So if I go and grab, or I don't have anything like that at the moment. So let's go back into our ball and chain because we haven't actually set up our grab points on our ball and chain. So let's go, and we're going to do that purely on that one. And again, we can pick up any of these individual things, but we're going to use our raycast there. But let's say that we add a grab point over here. Now, this grab point, I can say whether it's for the left hand or right hand. But I can show my hand here. So let's say this is for the left hand. So if the left hand picks this up, I want to place, don't do that. I want to place my left hand like this. Now, I don't have posing yet. Do I want it like that? No, I want it the other way around. I want you to be like this. Now, like this. Okay, so the left hand picks it up and it's sticking out. Now, really, I wouldn't mind it being anywhere on that, but whatever. Make it a bit lower, make it a bit more like this. Cool. All right. Sweet. Okay. All right. So, as you can see, that grab point, this is now positioned on that bone. And that is what I'm doing here with my, where were you? There's my pickup. Here we go. So with my left hand attachment, I'm actually attaching that to the left hand bone in my hand. So actually I want to go and open that. So here we have our hand GLTF. Here we have our hand GLTF. Hello, hand GLTF. Can I see the skeleton in here? Skeleton, here we go. But I can't really select it. Okay. But the funky bit about all of this is even though our left hand bone is right over there and is the root of this, there's actually another bone called the palm bone that is being tracked. And you'll see that being reported here the whole time where it says, I can't find the left palm, I can't find the right palm. That's because that's not a bone that is in there. But the left palm and the right palm is actually the root node of the tracking data that we're getting from OpenXR, and that we've also based our tracking data on in Godot itself. Now, one of the really annoying thing is, so wherever that left palm is, that is actually where our collision hand ends up being. The orientation of that is absolutely insane. It's got a really weird rotation, and then through the left palm to the left hand bone, that orientation is corrected. And that is why I chose to make that bone of my cat. Stop it. Stop being so annoying. That's why I chose that, because also that position, so wherever my left collision hand eventually ends up through my tracking, that position is different from runtime to runtime. So my left hand bone is actually the first one that I can trust is positioned in a way that makes sense for where my hand is positioned. So that's kind of important that we use that correctly. Now, with my grab point here, and again, I haven't done posing yet. That's another thing that we want to do. So let's make that left grab point. And now I'm going to add a second grab point. And that one's going to be my right grab point. And let's just not show that for now. Actually, I do want to show that for now because then my right one needs to be like that, and then like that, and then like that. I just want to start with that. And here, I want to make sure rotation is actually proper like that. Same here. Let's make that a nice and round rotation. There we go. And let's go and put those both on the same height, so that at least is the same. But now I'm just going to visually position. Oops. I'm just going to visually position my right hand like that. Again, I am not curling my hands yet, so that's just going to keep reacting to tracking. But yeah, so there we go. We have our two hands on there, so we can actually do that. And then probably in this case, I actually want them to be exclusive and only if not picked up. And here as well, exclusive. So I can't pick the bottom up with two hands. I can pick the bottom up with one hand and then do anything of the rest with the other hand. But I've now isolated that I can only pick up this with one hand. So again, the point is I now have that left grab point. It's actually on a really weird position because that we're actually doing it on the base of the hand. So going back to our code here, which of course moved. Going back to our code here, that is what I'm trying to do here is I'm actually getting the parent offset, which is that one. And I'm getting an offset between where my hand is and where that is. Now, that is going to be really interesting. Because with our new approach, oh, and that is why we're doing that. So taking that offset and then applying that to our destination transform gives us where our hand collision is supposed to be. Okay. All right. Go away. And we're about to change that quite drastically. That is not how this is going to work anymore. Well, kind of. Because okay, so that is that offset. Okay, cool. That is our actual destination. And what we actually now need is from that transform and the center location of the thing that we've just picked up. That is going to be our target. All right, so I'm actually gonna right now say if false, we're gonna park all this. Oh, we just broke picking up. Including the tween, because the tween, we're actually probably gonna do the tween on as part of our override stuff. You keep this. Okay. Meow. 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 You're really wanting attention, huh? You're not really getting into the camera. Yeah, you hate being picked up like that. Now you want to go, huh? But people want to see you. You need to look at the camera. No, go then. She hates being picked up. She likes pets. She likes attention. Picking up, not so much. All right. So. Okay. Get sets. And actually, I can move that a little bit up. I think that is something that I want to do over here. So get the offsets between our hands, root bone, and our hands position. I'm actually going to call that hand offsets. There we go. There we go. Cool. Just want to make that name a little bit clearer because that took a while before we figured out what does that do. Now we're going to get our grab points. Now we're going to adjust destination. Nope. Destination by our hand offset. So that's basically this. Best transform is that. Cool. And we probably can still use that as a trick. All right. So adjust destination by our hand offset. Cool. And now, apply target overrule. So, XR, add target override. Okay. Picked up. And now we need to have that. So that I think picked up dot. I always get this the wrong way around. Inverse times test. Okay. That is priority. Cool. So when we pick it up, we set our target override. Which means that now when we drop it, we obviously need to remove that. So, okay, so drop object. We drop object, da 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 da. We have a remote transform, do that. We have between, we kill. If collision hands, we had the join. And then we just killed that already? Why are we killing it twice? I think we're double kill, so don't care about that. That's to reset that little funky overrule thing that we did. Really? So we really need to do something nicer with this. But I'm going to just leave that in there for now. Again, we're probably going to redo the same solution there for now, but eventually do that. So I'm going to do here joint and false. Overkill because we never created the joint in the first place. So what we're going to do here is XR collision hand. So let's remove target override. Pick up All right. So what we now have done is actually broken our pickup logic. And I'm more than happy that we did. So we've broken our pickup logic. However, we've made the start of this. So as we're moving our hand around, everything's still going to work. Then when we pick something up, we are going to determine where we're picking it up, determine the offsets that we need. So when we're picking up the box, that should be based on the raycast. When we're picking up the chain, ball and chain, provided we are picking it up by the handle, anything else is still raycast. Provided that we're picking it up by the handle, we are using our grab points, which will result in a twist. And that way, our grab points, we should really improve and do like a circular grab. But we'll figure that out. Might eventually do something nice with that, the circular grab point. That would be really cool. But we're now determining all that. And then we're using our target override to say, place the hand where you grab it on the object. And now it's going to stay there because we're planning to make the object move. Not yet moving our object. We're planning to add that in. All right. So the result should now be that we should see the hand in the correct place, but we're not actually picking up the object. The object should stay where it is. Let's see how well that reacts. Here we go. Oh, it is, of course. Yep, you're gonna fail because, of course, Steam Link stopped working. Why wouldn't it? All right. Am I Steam Link? I'm still connecting to Steam Link. Hello, Steam Link. Are you gonna work, Steam? It does not like me today. I have a feeling that if you don't put your headset on correctly when Steam Link is connecting, that it tells you, nope, I'm not gonna work. I have to wait. Here we go. I have to wait until Steam Link actually fully starts. So, here we go. We're over here. Thank you. And now I want to do that one. I don't like that when I set the font size, that it actually doesn't impact the size of the drops down. All right, so you guys can see what I'm seeing probably. Yep. All right, so now I can move. And hello, I'm picking up. So as you can see, that is where I picked up. We still have that, all that works. That's pretty cool. Yeah, it's capacitive sensors. Yay. So yeah, our hand is animating like this. We can see our ghost hand where we want it to be. So that's still working. But hello, Mr. Cube. You are no longer working. And then I let go. My hand goes back there. If I, oh, what's that about? Why? Okay, so one other thing that I wonder is when I freeze it, maybe my collisions still work. Like, you know, hold on, in the middle of the stream, I'll talk to you in a bit. So that still works as well. And then, of course, so that is, yeah, I'm my ball and chain. Cool. My ball and chain was hit my pit controller and changed all my values. Yay! Okay. So this is working. However, we are having our hands collide with our object. And that's something that we still need to fix. And we will. Maybe we need to fix that right away. Could be. All right. Oops. Yep. Main. Freeze mode, static, kinematic. Yeah. Thought I actually already did that. I think this is something that we need to do as well. Is I'm actually going to add a new distance to that, and that's probably going to be a property of the actual pickup, so that we can decide, okay, are we too far away? If so, we drop. And I'll worry about that later. Nope. There's a pickup function. Pickup function here. Where are we? So do that, do that. The thing that I'm thinking of right now, and I thought I did that. Collision layer, pick up edge. Original, picked up collision layer, so is that really something we still want to do? I don't think we change. Oh no, we only do the collision layer there. Okay, yeah, that makes sense. It's primary. All right, and extra player object. So then we create an exception with the player object. So we make sure that whatever we pick up, we can't hit the player with. That's good. But I think we also need to make an exception. All right, so we drop, blah, 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 drop. Here we check if we're an other, then the other becomes the primary, and else we do that. Cool. So what I want to add in here, and I'm just going to do that for the controller or the collision hands version first. Yeah, we need to do that too. So we're going to make a collision exception between okay. Pick up. Collision hand. And obviously on drop, we want to undo that. That is then what? Ooh. Guess we never removed the collision exception. Oops, that didn't work very well. Which is interesting because in our raycast body, we were, when we do our raycast. Oh. 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 Ha! Right. I'm pretty sure that I implemented that. Did I implement that in one of my tests? I must have implemented it in one of my tests. This one? Oh. Okay. I'm not sure. Anyway, I'm pretty sure that I did this somewhere else, but I must have forgotten to do it here. However, get collision exceptions. Let's just put it in. So. Array. Grid. Oops. Other way around, Baz. So we are going to include everything that we have as exceptions to our raycast query, so that if we swing something underneath us, we are not going to jump up anymore. I thought I had put that in as a thing, but I guess I didn't. I must have done that in one of my experiments and not copied it over to here. Great find. Glad we fixed that. Okay, so now back to the picker function. That was a bit of a distraction. So now we're going to make sure that when we pick something up, we no longer collide with the thing that we picked up. Great. Does mean that as we move around, our hand can collide with other things and potentially do something with that. We will see. I don't think this will prevent us from putting our hand through a wall, but we will be prevented from putting an object through a wall. All right. So we now have that collision exception that should hopefully solve that issue. Now I want to go and reintroduce this. Because that should still work. Because all we're doing now is that after we have done all that, I actually want to do this. So I want to make sure that it is actually placed there. And we're going to go and add a target override. Now, this is a bit of cheating because I'm assuming that I'm going to be the only target override. No, actually, I don't want to do this. I think in the target override, now that we're doing that, what if I target his size? Dang, dang. Yep. And oh, dang. This process. We're actually going to position it right away. Okay, we might need to do a check there if let's actually do that. Because if we are disabled, we are not going to get there. Any other case? Yeah, I'm gonna leave that alone. That'll work itself out. Obviously. Again, very much edge casey. I don't think that if collision hand mode is disabled, we would have much of this logic working anyway, but let's just only position it if we should normally get to that code. Okay, so now we have that gets automatically set. And then here, and I'm actually going to go and put a note here and say, we should have a nice solution in XOR collision and for this. So what we're basically doing is when we add our override, we are putting our collision hand where we want it to be on our object. But now here we are positioning the actual hand mesh inside to where it was. You know, remember this hand transform is what we started with when we grab that. And then we're doing a tween that that moves that transform back to 0. It just places it back to where it was. Thank you for coming. Very cool. Happy. That's what we want. So yeah, that makes that so much easier. Okay. All right. Now, one of the things that I think is going to happen soon, that we are going to do this even for static bodies, unless there is something that we add as a marker that prevents a pickup, which means that if we grab a static body, all this logic still applies. We're going to figure out where on the static body we are. We are going to do something with that. All right, I'm actually going to get rid of this. Okay, and I'm actually going to do that right away. We are going to get rid of that. We're going to assume, or actually, no, I'm going to comment that out because I need that later on. Because we're going to do that somewhere else. So, okay, all that. Bum, 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 bum. Bum, 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 bum. Rid of that. Okay. Now I want to go and okay. Hand can also be found in the controller. We just need to send the signal that the user can input. Okay, so that's something we need to do there. All right. Now the other thing that I really want to do there is pick the body. So we are actually going to take that out. To do, we can only take out static bodies controller node. No, actually, I don't care about that because we've already made a remark that we might change that. Instead, here, what I need to do is to do add a decorator, or something, logic, no, to check if we can pick up objects. Might already might need to implement in our closest. And that's actually a really good one because we've got get closest here, ancestor of if, yeah, we actually already have that. Okay, so I'm going to go back to this in a sec. Now I'm going to go back to get pickup. Where's my pickup function? Pickup object. So I don't actually care about this. All right, cool. Now, where's my get closest? Get closest. Texture monitor, overlapping bodies, blah, blah, body overlapping bodies. Is ancestor continues, ancestor, so we can't pick up something that is already attached to us. We can't pick up something that is part of our origin. If our is a rigid body and that body is not frozen, we can pick it up. If it's a physical bone and we are using a collision hand, we can pick it up. I'm going to do the same for static bodies. Is if it's static body and collision hands, then in this guys, we're actually going to do pass. And then here, that is the thing. We need to do something that we can actually exclude static bodies. But for now, we're just going to pretend that we can grab anything. We can grab the table, we can grab all sorts of stuff. So let's have a look if this actually works. Yeah. I just want to chase this camera. There we go. So, all right. So I'm going to start with trying to grab this thing, and that's still working. And this time we don't have nasty things with collisions. Cool. One of the other things that I want to do, that we're not going to do today, but I'm going to do in the future, is when I let go, is instead of removing the collision exceptions immediately, I want to delay that. I'm actually going to go and put a note of that in there. But I should now, in theory, be able to grab that. Now, here we can see that our logic for where we're grabbing is wrong. So the reason why, also letting go doesn't work. So I still need to fix that. So we screwed that up right now. So the thing is, what we just saw happen here is I'm doing a raycast from where my hand is to the center of my object, which for the wall is actually on the floor. And then I'm checking where I'm hitting it. And obviously, that's not what we need to do. We need to actually find what is the closest point of interaction. So we're probably eventually actually going to do that based on our on our actual collision shape and actually do a proper collision check there to see, okay, where is the closest point that we are that we're hitting that instead of doing the raycast. So that's not for now. That's for later. But yeah, and I think I might even be able to do that. Oh, that's because we are using an area. Okay. Anyway. And the other thing that I think that just went wrong here, which is why that collision exception is important. Oh, pick up. There we go. And probably why we haven't had that trouble before yet. The fact that we okay. Excuse me. Where's my bloody collision exception code? Held object. So the fact that this was broken. Where are you? Went too far? Over here. Drop object. The fact that this was broken and we kept the collision exception in there probably saved us at some point. Delay this until we're not colliding. And we need to do the same thing here. So this is where we really need that collision exception manager. So what I want to change this to is before we remove a collision exception is that we actually check if we are still colliding between these objects. And if so, we want to pause with removing the collision exception. So we need some sort of collision manager. Not going to worry about that right now. Right now, our problem was because of badly placing something on the static wall. We will deal with that eventually. Now, with our closest object, where's my closest object? Okay, we're doing all that. Pick up a grab point, get closest grab points. Build on closest grab point. Grab points. So yeah, here, intersect ray. Intersect point, no. Intersect shape. What do you mean shape index? Oh, that's what it turns. Okay, so I need to go there. Oh, okay. Shape as a resource. Okay. Yeah, that's what I remember. That's the problem that I had with this. Do that. Here we just do, we assume that our closest collider is going to be our objects. I'm not going to worry about this. I'm just going to put a to do here. To do. Change this to shape. Cast. Using our area collision So the thing is, because our area is obviously already determining what's within range, so we should have a collision with that, or else we wouldn't be coming in this logic. And what we just want to find out, what is our closest location to that area that we are colliding with, and that becomes our actual point, and that should be much better than using this raycasting. But I don't want to go down a tangent just yet. I want to first get our pickup logic to work. So objects, blah blah blah. Yep, that's all good. So we've got all that working. All right. So we've got that there. We got a target override. We've got our collision exception. And then our remove. We obviously, again, we want to do a manager object eventually there. Now it's time that we actually add in. Oh, that's bigger than I thought. A physics update. Okay. Let's put them there. And then here, obviously, we want to make sure we don't run that in editor. Next thing that we want to do is, if we do not have a picked up object, there's nothing to do here. Okay. Now the next thing that I want to do is when I'm going to look at my it's a good one. This is just a node 3D. Should. Where's my collision hands? Here's my collision hands. Where's my ready function? Here's my ready function. 90. Where is this? Pick up. Ready. I always forget which way around this priority works. Because I really want to make sure that this runs after our XR origin, or sorry, our collision end. So we might actually need to go in the other way. But when we look at our locomotion handler, what are we using here? 92. That would suggest that this runs before the other one. So you might need to flop them the other way around. I don't know if I actually have search, find in files, -91, find just here. So worst case, we flip this around, make this 90 and make the collision hands 91. We will see. Or else, might lag behind a frame. We'll see how that goes. Oh, that is the other thing that's, of course. No, I do want them to be that way around. Because okay, so that means what does that mean? the thing that I'm thinking about right now, the thing that I'm wondering about is if we position the object first and then position the hands, we get the hands in the right place because it's placed on top of the object. But if we would, in our pickup function, handle the position of the XR controller directly, we would be using last frame's position. Doing it the other way around and running the hand logic first and then the pickup logic, that means that the hand is correctly positioned where our tracking data is right now. But that means that, yeah, our hand position is correct. So our picked up object will be placed correctly. But because we placed the our hand mesh in the right location before we actually move the picked up object, that will be out of sync. So we have to run the pickup logic first, which hopefully the lower priority number does. But again, it might need to be flipped around. But I think it also means that we can't just grab the location from here. I want that hidden. So when we look at this, we are nicely doing all this. And I think that I'm going to want to put that logic into somewhere else. Now for the XR controller, it's fine because our XR controller is actually positioned before our physics process runs. But for our collision hands, we don't. Okay, so. We want to get out of here. We don't do any height logic here, I think. Do we do this anywhere? Anywhere else? With the map? Okay, hash tracking data we do, yeah. No, we just do this. Yeah, we probably want to do that as a return value. Do we have that option in GDScript? Can we pass a parameter by reference? I am not entirely sure. Okay, hold on. Do pass parameter by. No, we don't have a pass by reference. Okay. Um, we can assume that if we have a target origin of 0, 0, 0, then that is wrong, but hmm. If we don't have tracking information, yeah, because this is we do have the ability to have a null transform. Okay, cool. So we're going to actually make a nice function for this that we want to be able to pose. Data. Okay, so here we want to do a func get track transform 3D. So we can't return a transform 3D as null. So that just becomes transform. Again, the likelihood of it exactly being that is really, really slim because that means that our hand is on the floor right in the middle. But hey, Cryo, I build a whole bunch of logic to make sure that as my hand's tracked, that my virtual hands nicely follow and properly do physics and blah, blah, blah. But when we pick up an object, I was using a approach where I create a join between the hand and the object that I pick up. And it works really well, but it gives really weird issues when picking up objects that have other types of constraints. So what I'm trying to do right now is create a system where, or I'm evaluating if that works, is where instead, if I pick something up and I start applying the forces to the thing that I've picked up and I just have the hand following, whether that's going to work better. However, that means quite some hectic changes. And yeah, we're going to have to figure out how that exactly works. So in here, we were having that. So we're actually going to do target is get track transform. Boom. Oh, that's going on. Not going to worry about that just yet. Okay, that's going to go out because we're eventually going to check whether we actually have a transform value there. So now I need to go back to get track transform. It's going to now be that. If we have a hand tracker and we find that, I'm just going to return that one without any problems. There we go. Well, we're returning, so we no longer have to do that. We can just do this. All right, there. We have a fallback. No. In this case, it's going to be target transform 3D. There we go. So we have basis from that, and that. We don't need you. go, say return. Okay. And what we're going to do here is we're just going to add in a to-do. If that is grip, repose, must adjust angle. All right, so if we're going to end up using the grip pose, we need to do some more there, but we're not too worried about that. Well, we do all sorts of VR stuff here, so you'll see it in action in a minute. All right, so there we go. Okay, so we are getting that. And in this case, we're going to see, say, if, I don't know if this works. I don't know if we've got a, something that is close to this. Okay, north, it's not tracking. Ident transform is very unlikely if we are. And else we might need to do something else. You know, we could do something crazy like put the Y like, I don't know, very, very high. Okay. All right, so I want to test this out first to see if we haven't broken things. Here, we're not doing anything yet. Cool, so we can. All right, let's hope that my, did I? Yeah, I did that too quick, didn't I? Ah, bloody hell. Yep. I really dislike this. When I'm coding and I don't have my headset on, because my headset is very uncomfortable having on my head the whole time, Steam Link keeps crapping out on me. Okay. And of course, it's going to do that. Your session is not correct. No, because I'm starting a new one, you dumb thing. All right, try again. Here we go. Now we're in. All righty. Late. Come on. Yeah, oh, I thought so. Then I wonder, is it only going to do it when I am there? Okay, so here we go. We are still working. Yes. I'm just going to go around the back again because it's easier to get to the cubes. And yeah, still working. So again, not doing that. So here we say I got the same thing, right? I'm going to go and solve that soon because we're doing that raycast to try and figure out, okay, where are you closest? And then doing that. So don't do that. So yeah, we're going to want to do that nicer. See what happens actually if I do this. Okay, because that's the other thing. I don't actually like. It's good that we tested that the graph points still work, but obviously. Oh. Ah, I did the right hand wrong anyway. That does work. I can do that. That does work. Okay, so actually one of the things that I want to do, even though that is kind of a little bit dumb what I've done there, but put a ball and chain for my right grab point. Let's make that visible. I actually have my hand the wrong way around. So that is like that. Okay, that's gone good. And then, God, should have dug again. Again, I don't really care about the exact positioning. It's just for testing right now. That'll do. Okay. Again, I think that this is one where I wouldn't use the grab points, where I just grab it at the closest point But I need to fix that closest point. Anyway, so cool. We are getting closer and closer to where we want to be. So we can now get our tracked transform from our from that. Okay, so okay. If Xbox controller, oh, collision hands, then target is that. I'm on 4.5 right now. You can actually see it in the. Oh no, you guys can't because my camera is in the way. Sorry. Yeah, no, I'm using 4.5, and that's really because I want XR Tools to be compatible with that. So in this case, I can actually transform. Cool. Okay. Sweet. And else, if some I don't have either, we're going to return. And I should do global transform. Okay, so now we need to go back to a pickup. No. Pickup objects. Because we calculated this nicely. And we actually want to store that. Because we're going to have to apply that to our logic. Okay, so let's go and... Because in this case, we are going to be... Yeah, we are going to be doing that, applying that offset there. Okay, so picked up objects, grab points, and grab offsets as a transform 3D. Okay, pick up objects here, grab offsets equals this. That's actually no. Come on, give me my help back. There we go. Yeah. Grab offsets. So now we've got that stored. Obviously on our drop, I want to go and ooh, that's why that wasn't working. Okay. Because we did that differently. That's old code now. There we go. Shoot. We really need to move that into our collision hand. And I just want to actually, you know what? Yeah, that's fine. And here as well. There we go. Cool. Okay, that should at least fix that issue. Screws as the fail you have looks like it uses a K, so I was wondering if you were using. No, I'm not using a K at the moment, not for this. I am very much looking forward to using the new IK logic. So I have used the current version of IK that's in 4.5 for a number of experiments to sort of have an avatar follow my VR character around. But it's usable, but it's not great. But the new IK in 4.6 is supposed to solve a lot of issues there. So yeah, very much looking forward to that. Okay. So that is our offset. And that is the offset that we apply to. Yeah, we do. So when we look at our, where's our helper? Helper. Yeah, we add that to our box or our rigid body. Cool. Yeah. Cool. And then there. So no. So when we look at our pickup logic, that's all the other one. Yeah. Yeah, because hand offset is that. That's based on the parent. Yeah. And transform is where we are. Then, oh yeah, then that's the hand offset. Yes, that's okay. So yeah, that then becomes our offset to go from our destination to our global. Yeah, and we do that there because we've got a destination. So add the hand offset there. That gives us the actual controller location. And then here, we're going to look at the control location offset to where the center of a picked up object is. That becomes a grab offset. Cool. Perfect. So everything is done on the collision hand location. All right, cool. I think we're very close to having this work for both collision hand and XR controller. Yeah. Although I don't have a example here of making it work with the XR controller, but that's fine. Anyway, I think we've got all the ingredients now. That's a physics process. So let's first get it to work just with the basics. So indeed. Here we're gonna do to do if static body apply forces to player. Okay. Sweet. All right. If it's a physical body, a rigid body, or a physical bone, we're going to apply the forces to those. Alrighty. Okay. Okay, so in this case, we're gonna go and apply some stuff to that. Okay, so let's go over here. Got our target. I'm gonna ignore that for just for now. I'm going to go and put that in here. Do-do, fly. Do-do. Do-do. Okay. Blah. And then we can pretty much go and add these in. All right, so we have delta. We're not going to apply that to self. We're going to apply that to picked up. We have a target. We don't have these guys. So linear proportional gain floats. Very bad default value. That's that one. We're going to give these something meaningful later. For now, we are going to go and copy these from there. Because that's the only situation where we're using them. Now, all right. And I'm just standing to put that in. Set the var. There we go. 0 to 0. All right. So that does all that. That does all that. I'm actually surprised that I think is a bug because I did do that over here, didn't I? Here. Because did the global position, but I never did var parent global bases. Bases. Now global bases is parent body dot global bases. Underscore parent body. Because of course, if we didn't have a parent body, that would have ended up really badly. So, Toto, do. Thank you, Baz. You can learn to spell one of these days. Okay, cool. That should, in theory, apply those. Now, obviously, here we need to. What did we call that? So we called that grab underscore grab offset. That's what needs to go in there. Hold on. Is it? then it also does the orientation. Okay, so I might need to That is interesting. That might work. Yeah, because for positioning, we care about the rotation. Does that also mean sorry, this is in that? I think in this case, I'm actually going to also need to do yeah, I think so. This case, this might actually end up yeah, I think I just need to grab the origin here. And I think here we do grab offset dots bases. And we got to apply torque, and we want to have I'm going to call that the same. That's going to be a bases. There we go. Means that I want to do that here, obviously, as well. We're get in trouble. How do we call that here? Target global bases. Yep. Huh? No. Apply two global bases. Oh, that's because that, yeah, offset in global space. Because that's the logo target. Target orientation. Yeah, or oh, that's because I call that target offset. Okay, yeah, right. So this is original bases is going to be apply to global bases times targets offset. There we go. Okay. These might need to be the other way around. I'm not sure. But I think that now would work. And then we have our applied torque. Actually, that's interesting. That might need to be. That might need to be the other way around. Hmm. Because we want the rotation in the local orientation of that. So this is actually going to be adjusted target orientation. And that is actually going to be our global target orientation. And again, this might need to be the other way around. Inverse. Because here we're doing everything nicely in global space, which makes it so much easier. But here we're doing it in the local space of our picked up object. Which means that we need to rotate our orientation of our controller into our local rotation, or our rotation of our target. So by doing that, now we get the angle that our picked up object needs to rotate, and we do all that. I think that is all. Yeah, that makes sense. So yeah, we get the target rotation of the object that we have. Cool. Yeah, I think that's going to work. I think that's going to work. So in here, we have that. We need a comma. There we go. And we probably forgot that somewhere else. Of course we did. Why would we not do that always? All right. So obviously, we're not doing our parent adjustments. So if we move, we're not going to see the correct stuff. The other thing, in applied torque, we didn't do inertia. That's going to be a problem. What did I do for inertia here? Did I already turn that off? Yeah, I'm still turning inertia off. Which also means that, or I'm making inertia very low, which also means that our current values are going to be wrong. Ooh, that's a really good one. The problem with vector math is it is really hard to get your wrap your head around, especially when you're dealing with rotations. When you're dealing with linear motion, it is just a matter of working with them. But good, the problem is I have learned this over years and years and years. So I remember back in the 90s, I had some really good books on it that sort of taught me the basics, but that's not useful information anymore today, right? It doesn't really make much of a point. So yeah. Anyway, we're going to test run it the way that it is right now, but because we're not taking inertia into account, and the object that we have picked up, it doesn't have inertia, we have a problem with this. So, okay. Let's see. And this is where we're going to eventually need state, because we're going to want to apply the correct inertia value here. So I'm not expecting, once we pick it up, I'm expecting position to be okay, but I'm not expecting orientation to be okay. I think orientation is going to be laughably wrong. And of course, let me guess, Steam Link has kicked the bucket again, hasn't it? Yep, it has. Oh my god. I should have just start a developer hub and turn off the proximity sensor. That would keep it alive, but it also would drain my battery like crazy. All right, and it's of course going, your session ID is wrong. Yeah, because I'm trying to start a new session. Come on. If anybody from Valve is watching this, please make Steam Link reconnect more easily, because this is the way we work. Okay. All right. Hold on. I just want to try this. Okay. And again, I need to do something more with the camera, actually. And I need to really make that accessible from inside here. Okay. So I grab. Whoa! Well, seeing that it's moving in mirror, my problem is definitely positioning. And seeing that it's over there. That was funny. That was funny as. Okay. So definitely the rotation issue is there. So the problem here is when I look at my collision hands function that I just added in. Okay. I bet you that if I look at my physics process, I get my target, and then here I make it in the right space. Okay. So I actually want that to be part of my get track transfer. Oh, you know what? I'm just going to give that as a parameter. I'm going to go and take you away. And I'm going to say here is actually I'm going to do that like this. Transform 3D is transform 3D. There we go. Hold on. I'll answer your question in a sec. All right, so that should work. All right, so you said it. Rotations are what I primarily struggle with. I have a non-standard understanding of what a basis is. Okay. Oh, why do I have messages? Sending me messages. We'll answer that in a minute. Built-in types cannot be. Yeah, that's not gonna work. Oh, but now that's actually pretty useless. No, I am actually not going to do that as a parameter. I am going to do is parent. Sad that this is going to be double. Our parent node is if parents actually I'm going to do it here. There we go. Okay. Actually, I'm going to make it fit true. And I can do it like that. So, no, we just had it in local. So, transforms. Okay. Godot has this thing called a transform 3D. As the description you said, it's basically a 3x4 matrix. So matrix is the bread and butter of rendering engines for handling positioning and rotation. There's a whole bunch of really funky math behind it, but yeah. So we have two components in a transform. We have a basis, which is your orientation. And we have an origin, which is your position. Origin is obviously just a vector. You know, if the vector is 10, 0, 10, that means that we're somewhere 10 meters to the front and 10 meters to the side on the floor, assuming it's a global coordinate. Basis is your orientation. And literally, when you look at an object and you see the three vectors sticking out, so the green vector up, the blue vector forward or backwards, and the red vector for X. When I rotate this box, see how those vectors rotate with the box? I put it on the local space so that we can see that. And I go up and down. So that is how, when you change the orientation of a box, those three vectors change. Now, when you look at the bases behind the scenes, it actually stores those three vectors in a 3x3 matrix. Because it turns out that if you take an arbitrary point in space and you multiply it in a certain sequence with those three vectors, you get that point. So let's say that it's the point of our box here. And now I rotate that. So my original point was here. If I multiply that point in a specific order with those three vectors, I actually end up with the rotated point. Now, that's the underlying stuff. And I'm skipping over a whole bunch of things of understanding of what that actually means and how that actually works. And the fact that you know, if you have an orientation basis, you can multiply it with another orientation basis, and you actually end up with the accumulated rotation. So if one rotation rotates the cube this way, and then another rotation rotates the cube another way, if you multiply those two bases together, you end up with the basis that combines those two rotations. So you can get very complex sequences of rotations all multiplied together, end up with the basis value that is the end result of that, which makes it so much more efficient to do these things. Depending on what it is that you do or what you want to achieve, generally you're not going to work on that nitty-gritty, on that low end of, okay, I need to understand that the basis is those three vectors, and that somehow magically anything that I rotate with that is going to be rotated into that orientation. It's kind of like a black box. You need to know that that's what it does. And then, 9 out of 10 times you can just apply the rotations to what you're trying to achieve by looking at the functions that basis offers. So basis can be set up. If you look at the basis itself, do I still have that open? No. So if we go transform, yeah, if you go to basis. So if you look at the basis setup, you can see that we can construct the basis from a number of things. First, from another basis that's just a copy. But then we can create a basis from an axis and an angle, which is what I'm using a lot at the moment behind the scenes. So in this case, the axis is the axis under which you rotate. So that's a vector pointing out of your box or object. And now you're saying, I'm going to rotate around that axis. So you then give an angle in radians, how much you want to rotate at. And behind the scenes, it will calculate the basis for you that does that. I'm not going to touch on quaternions, but quaternions is basically that stored in a more efficient format. So it's another way to define an orientation. there are advantages to using quaternions. There are advantages to doing bases. Quaternions can't be scaled. Bases can, for instance. But yeah, quaternions they do allow you to do some cool things. They're almost interchangeable. It's just that's a more efficient format. And then obviously we can construct the bases from those three axes. If you happen to know them, then you can create them. That's probably the one that you would use most. So for instance, if you want to rotate something around the y-axis, you would just say, vector 3 up, and then angle, degree to radians, 45, means that you now have a rotation around the y-axis, 45 degrees. So that's how you define the bases. Yeah, so when you look at something like, for instance, making the player look in a direction, you would do that through a basis, but there's a secret ingredient here. You have some secrets. First of all, in this case, you wouldn't actually work on the basis. You would work on the transform. So if you go back to the transform, you have a transform property of your character body, right? Also, another important thing, you have a local transform, which is the dot transform property, which is your position and orientation in reference to whatever the parent of the character body is. And you have your global transform, which is your transform in the world. Very important distinction for character body, for the work that you're probably doing. They're probably going to be the same because you're just going to have your character body in there. Yep, you're already seeing here. We have a looking at, and you actually on the node 3D, you have a look at that works a little bit better even. But yeah, you can have the looking at to make that character look in that direction. And again, on the transform, you have it, but you actually have a shortcut. So you go to node 3D. You will see that there is indeed a look at function here. I think it's from here. Yeah, look at. So here you simply say, hey, look at, and you tell it where to look at. And then obviously you can leave those mostly alone. Although in many situations you might want to put that to true. For player characters, usually false. For other objects, usually true. A little bit of experimentation. So behind the scenes, when you call look at, it's actually calling that looking at function on the transform of this node to get a transform that applies that. So it's really important to just use the docs, look at what functions there are, understand that a transform combines position and orientation. Basis, just the orientation. Various way to construct them, but most important thing is like with basis for rotation is that axis and angle one. That's usually the most. So like if you want to rotate your player by 30 degrees, axis up, deck to red 30, you would have a basis that rotates about 30 degrees. And then the key is that you can just multiply these things together. And you multiply them in reverse order. That's the thing that people forget, is the last transform that you multiply with, or the last basis that you multiply with, is basically the first rotation or adjustment that is applied, and then you add them all together. That is why in the code that I was just writing just a minute ago, in here, you can see, for instance, here I'm going from target. This is a little offset transform that I create, that I then multiply by the transform from my tracking system, that I then multiply with my parent transform. So that's the last one that actually gets applied. So it looks really weird that it's actually in reverse order. If you then want to now apply this transform to a vector to get that vector transformed into space, that would go at the end. So it's kind of a little bit weird that that is the order in which it goes. And that's just convention. That's just the way that it eventually works. Anyway, I want to kind of finish what we're doing because it's nearly dinner time over here and I'm starting to get hungry. So our mistake here was that our track transform that we're getting over here was in local space. So I had moved my character all the way around the table, and the target position that I got is actually where I started out at the beginning, which is why the box flew off to where I was in the beginning. It was also rotating out of control, but I think that was mostly a factor of not applying the right inertia. All right, cool. Sweet. So let's try this again. And obviously we can validate that by just faking the inertia for a minute and just turning the inertia of our object off. So you can see that now the position is correct, but it's rotating like crazy. And I am pretty damn sure that either we're applying our offset incorrectly, which is very possible, or oops, or this is because our inertia being absolutely crazy. Oh, definitely doesn't like that. I think that is probably got to do. No, I don't know why that is. Anyway, wink. So we're getting close. Now there are two options. One is that what we were doing with our adjustments. Let's try that first. So on our applied torque, we're applying that grab offset basis. So let's assume for a second that we just did those in the wrong order. I'm not quite sure if rotations matter, actually. It matters when we are doing transforms. The order becomes really important. But I think with rotations, it doesn't matter. So it might just be that we are dealing with, yeah, same problem. Boink. All right. Okay. I'm going to do something. Excuse me. Really evil here for a sec. Excuse me. And that is just for now, just for the test. Yeah, going. I am going to go to my world and I'm going to go to my box. I think that is the big one. Yeah. And we are going to override the inertia. So we're going to go and turn the inertia off and see if it then works properly, because that would hopefully confirm my theory that we're just applying the wrong torque for this. No. So that is an incorrect theory. Whee! That is funny. Okay, so on these it doesn't do it correctly. Yep, yeah, I know. I just jumped over my cube. This is why I want to have a delay on removing the collision exception. Anyway. So I think with that done, I'm gonna go and reset this again. Actually do that. I think that is pretty much evidence that we are definitely making a more critical mistake here. I'm actually gonna put this, oops, back to where it was. Okay. All right. Before we do anything else, I'm going to go to pickup, and I'm going to disable this for now. The other thing that this pass I no longer need. Other thing that I want to do here is if is primary. You're only going to do that on the primary. and Baron Buddy. Okay. All right, so there we go. All right, this is the last thing that I'm going to do. I just wanted to double check if what I'm doing. Oh, there you go. What I'm doing movement-wise is indeed correct, because now I should be able to two-hand do this. No, it's not. So, unless I didn't save something. So I'm guessing my problem is actually that I'm trying to be too smart. And I think that I shouldn't be doing this. I think because I am applying my movement force on the side of the cube, it is starting to spin. Now, maybe it should, and then combat with the force that I'm applying with my hands. But it's also possible that this just really doesn't work properly. Okay. Alrighty. So, okay, so that is working, but that it doesn't like. So, yeah. I still think that I think that actually applying the force like this is probably correct. However, no. I think I already know what's going on. I think this is correct. But target origin I think I do need to do this as vector 3. Because it's not just position, it's also the orientation. I'm not sure. Although I think I might need to do it against the inverse of that. No, definitely it's not working the way that it should. Okay, guys, I'm going to call it there because I'm starting to get really hungry. My son came home a little while ago and I've not given him any attention. I think that either the grab offset is in the wrong way around, because the grab offset is the transfer. And I think I do need to take this as dot origin. Because it is the transform to get from the center of my picked up object to where my hand position is in the local space of that. No, it would then be the origin. So am I applying our orientation here? Because just want the offset there. And then I'm get my original position. And then I want to look at where I'm moving to. And then because it actually makes sense, right? If I grab a box and I just pull it from one side, and let's say that my hand's on the swivel, I'm not giving any force back, I would slowly push that side of the box to me. So I think that part would just be good. Yeah. Are you syncing the physics ray to your max refresh? Yes, I am. And this is also one of the reasons why I'm trying to go down this route, because I had most of it working through joints between the hand and the thing that I picked up. But at a 90 hertz refresh rate of physics, it really screwed up. And I'm hoping that by applying the forces to the object I'm picking up, that would stabilize things so that I didn't have to go to some crazy high refresh rate. But yeah. Anyway, I think we're really close to what we need to do. But I'm either making a mistake in my thoughts process here, or something here is working wrong. Did I get that the right way? Maybe we did put that the wrong force position. That's a positional force to the body. A force is time dependent. I meant, yeah, that's fine. Position is the offset from the body origin in global coordinates, and that's what we're doing. I don't know. Okay, to be continued, people. I'm in desperate need of some dinner. We're getting close. We are getting very close. I think we'll eventually figure out what we need to do here. Thanks. I might actually end up just resetting our resetting our linear proportional gain, just setting them to something very low so I can more easily see what's going on. But we'll see. Maybe I'll do another stream on this tomorrow and see if we can get some fodder. I am not sure, but I do feel we are getting very close. I am very happy with a lot of things that we did today, and we are getting closer and closer to this working in a way that makes sense. So pretty cool. Thanks everybody for watching, and I hope you will join me on another stream. So to be continued. Thank you so much, everybody.